Hello, wonderful people of the internet. Welcome back to another episode of Simuleos. I'm doing my best to make sure the volume is okay. Let me check that again. It might be a bit, well, okay. Let me know if you're having any problems with the volume or anything like that. I'm doing my best to get the sound all mixed appropriately, but sometimes I just don't do a good job of that. So if you hear my voice like railing, that is to say it's kind of like weird, like distorted because I'm speaking too loud or something like that, let me know. 715-209 TS Jost, Circumoto, Amaras, thank you guys so much for coming in. So today's going to be a double stream. It's the first time I've ever actually done one of these streams. I'm going to do 2 hours working on algorithm archive. I'm sorry. A bit too saturated. Okay, let me try that again. Okay, let's see. So you're saying it's a bit too saturated. So let me try this. Nope, that's too quiet. How about that? Okay. That looks good on my end, I think. Something like that. Nope, that's too high. How about how 1 second. How about this? That seems fine. Okay. Tunes in. Welcome to another episode of Streams Freezes. Let me see. I should have quality options, so I don't see why that would. Yeah, I don't know why the stream would freeze on you. I haven't dropped any frames, so sorry about that. Let's see. Thank you, Fate. Cool. Okay. So, still clipping a tiny, but it's fine. Okay, it shouldn't be clipping at all. Yeah, it's never going above the red, so it should be still fine. The problem is I can't really adequately, I can't check the sound while streaming is the problem. And I realized what I could do is I could just plug a second, well actually maybe I could. Let me see what I can do. 1 second. Maybe I can figure out exactly what I sound like. Because there is an output on this. Let me see. Can I hear myself? No. No, okay, never mind. I thought this would do something different. Can I do this? Now does it work? Hello? Hello? No, it doesn't work. I'm sorry, you guys don't even see what I'm doing. I was just checking with some audio on the side because I've got this in-out thing where I can like directly monitor what I sound like. So we're gonna see. X-serial killer. I'm very far from an X-serial killer. It's not clipping. It was on my end. Oh, fair enough. Hey Crophead, hey Gibbous. Let's see. I can hear you. Couldn't hear you because stream was muted. Oh, okay, cool. So I think all the sound issues are solved. Again, today's a double stream. I'm going to start for the first 2 hours doing climate machine stuff. So at what should be 6 o'clock p.m. Eastern time, which is again 2 hours from now, I'll then switch to the algorithm archive stuff with work on iterated function systems, so fractals and stuff like that. So that's going to be today's stream. So if you guys were here for yesterday's stream, you saw what we're doing with the climate machine stuff. And if you were here for a few streams ago, then you've seen what we did with the iterated function systems. It's going to be much the same to those two things. Let's see. I still do have a job, though. Thanks for greeting me, though. Oh, wait. Oh, X-serial killer / life. I could hear you. Let's see. I've been working on a new mod, Minecraft mod. Okay, so there's one more thing I'm going to address before stream starts, and that is, so you guys know I used to play a game called Guild Wars. So Guild Wars 1 just released a new update related to their anniversary celebration. Now I have streamed Guild Wars precisely twice on this stream, maybe 3 times depending on whether you count one particular stream I did a few years ago, but pretty much only streamed it twice. And I'm wondering if maybe over the weekend I should play the game to get the new skills that they have in the update. I'm considering doing that, but I don't know if that's actually something you guys would be interested in. I mean, I have a huge wealth of knowledge for the game. It's kind of interesting, and I kind of like watching people who know a lot about what they're talking about. At the same time, I do totally and completely understand that it might not be what people are interested in. I mean, let me just go to Twitch really here quick, and let's go to browse. I don't know. It was just something I thought it just happened, and I thought maybe you guys would be interested in it. I have no idea. And if we go to Guild Wars, nope, that's not how I search. I search up here. Number 2, right after Ring Fit Adventure. Guild Wars right here. 463 viewers. That's not bad. 10 new elite skills. I don't know. I mean, people are interested in it. Anyway, it's just something I wanted to bring in. I'm not going to talk about it too much. We're going to get right to the climate machine stuff. I just wanted to briefly mention it at the start of stream that something cool just happened, and I kind of want to, you know, like do some of it on stream, and I don't know if that's interesting for you guys or not. Maybe 3 times if you count that one particular stream a few years ago, but I was drunk, so I didn't. Oh wait, I didn't say I was drunk during that stream. It was a stream to test whether my streaming settings would work for video game playing. So I just chose Guildwars for that. And it refactored my script again, so that it gets the data it needs from a JSON file instead of a bunch of hard-coded if statement checks. Yeah, good luck. No, I'm not looking for someone to raid already. Anyway, I hope you guys are all having a wonderful day. Again, let me know if you have any issues with the volume of anything during this stream. I've been messing around with my volumes, and it seemed fine on my test streams, but it could still, there could still be issues. So just let me know if you see any. And without further ado, let's go ahead and get started talking about Klima and where we're going to go with it today. So if you were here for yesterday's stream, you would know a bit about Klima, also known as the Climate Machine. This is what I do mainly for work. It is essentially a new and improved climate simulator. That's the idea. It's written entirely in Julia, and right now we're tackling a very small-scale issue with it that has to do with using Klima on high-performance machines, specifically with GPUs. Now, if you were here for any of my streams dealing with my PhD, you'll know that this is very much in my ballpark. I do a lot of stuff with GPU computing. It's kind of my big thing. It's what I work on. So this is right up my alley, and we're going to be looking at the guts of a lot of the Julia internals, specifically to deal with reshaping arrays and stuff like that today. It's going to get kind of messy. So if you guys have any comments, questions, concerns, ideas, anything like that, as we're talking about this particular topic, feel free to let me know, and I'll do what I can to answer it as soon as I can. So what are we doing? Right, so we're using Julia, right? And again, if you've seen this stream before, you know about Julia. Feel free to ask questions about Julia if you have any. Point is, we're using Julia to access multiple GPUs, you could say. Now, again, how do we access data on multiple GPUs? Well, we have to send data between multiple GPUs. So this also means we have to deal with MPI, which is a message passing interface. It's the thing that allows for us to send messages between distributed objects. So between MPI and GPUs, we have this data structure known as an MPI state array. Okay, that's what the array is called. This is just a way that we're holding all the data, and it just happens to be a nice way to access elements. Now, what exactly is this? It's kind of a wrapper on top of either array or cuArray, depending on whether you're on the CPU or the GPU, right? So if you're on the GPU, it's a wrapper of cuArray. If you're on the CPU, it's a wrapper of array. This allows for us to do heterogeneous computing, which is quite cool. Also a pain in the butt for developers, but it's quite cool in the long run. Right, so because it's a wrapper on either array or cuArray, when we do a reshape, like we try to change the shape of our MPI state array, instead of that reshape function returning an MPI state array, it returns a reshaped array of the wrapper that is over array and cuArray, right? You expect a reshape to return an MPI state array, but instead it returns a reshaped array of an MPI state array. Now this sounds like it's not a big deal, right? It's just a bunch of types. It doesn't really matter that much, but it does matter because when we actually have to access elements of a reshaped array of an MPI state array, we can't do that. And so we run into a big error where, or a bit of an error where specifically when we have to reshape a cuArray, which is an array on a GPU, we're unable to access the elements of that array. And that's where we're at. Similar for reference, when you catch up on chat, start with, I've been working on a new mod sent by Crophead. Let's see. What? But I've already caught up on all of that. Like, I've already read all that. Let's see. Yeah, I already read all of the chat up to that statement, Gibbous. So, let's see. Cool. Okay. Oh, I meant by serial killer killing 0 points. Okay. But Gibbous, I've already read that whole statement. Like, I've read all of that already, so why would I read that? Like, that doesn't make sense to me. I'm working on a streaming extension that makes you share windows individually. That's really hard. Oh, actually, yeah, I could imagine that being pretty hard. All the messages after. No, that's what I said. We're saying the same thing. And so you're saying you want me to start reading from, I've been working on a new mod here. So you want me to read all this, but I already read all that. So I don't understand why you want me to read it again, unless you're having trouble reading it for some reason, in which case I guess that's fine. Oh, Slash Life, thank you so much for gifting a few subs a few minutes ago. I totally missed that. So TS Josh, Dallas, Full Dead, and Cobalt Ethan, all people who've been on the stream before. I really appreciate the gifted subs here. Let's go ahead and put a few Simulicows in chat. Let's do Simulicow. Let's do all three of them. Yeah, I really appreciate that, man. I appreciate all of the support you guys have provided to this channel so far. It's really cool. Right, I really appreciate it. And again, if you guys have any questions or anything like that, feel free to let me know. I just joined, so I apologize if this has already been covered, but why do you need to reshape the arrays? Couldn't you just change the GPU kernel to fit the existing data and save on the reshape cost? Right, so I agree with that statement, but the issue here is that the way in which we're writing this code is not always written in kernels. So the reason for this is because of the cuArray interface in Julia. So what you can do in Julia, which you can't do very easily, I will say, in CUDA or other languages, is if you have an array A, and let's say this array is a cuArray, right? You can modify the elements of an array A by let's do dot plus equals A. What this will do is it will do basically A, whatever your array is, plus A, but it will launch a kernel to do this operation element-wise, right? So what ends up happening is a lot of these kernels are developed kind of on the fly. So for users, it doesn't really make sense for them to create a specific kernel to do the data operations that they need. A lot of times they kind of want some sort of more high-level interface. So we're kind of, because there are a large number of developers on this particular project, we're kind of trying to create that middle layer to allow people to develop and iterate on this code faster at the physics side from the computational side. So that's kind of what we're focusing on. The reshape isn't particularly costly. I know it sounds costly, but we're not actually changing the underlying data. All we're doing is we're changing the way in which we access that data. So it's not super costly. But it's a good question. Thanks for asking. It just seemed to me like you did miss some of those messages since you didn't remark on them. And they were sent while you were drawing. Yeah, so sometimes, like, again, I try to read all the chat. Sometimes I don't read the chat aloud. It's kind of random whether I read the message or not. But I do usually read everything. I gave 3 subs to that guy with the laser and wooden board. And the laser put them next to your name. So I figured I need to retaliate here too. What? What is this? That guy with the laser and the... Oh, I see. Slash Life. I gotcha. I understand now. Right. I really appreciate it. So, cool. That's where we're at. So let's go ahead and show the bug. And then we'll try to talk about what we did yesterday and where we can go and how we fix it, all this kind of stuff. So CD into projects, Klima, over here. And we're going to do CD projects, Klima. And again, any questions, I welcome any questions. So please feel free to ask. Get branch. Yep. Okay. Get checkout. I'm going to go into reshape. Oh my gosh. MPI. MPI reshape. Okay, so now we should be on the right branch. And he missed a message about how he might have missed the messages sent while he was explaining because he was explaining. No, I didn't miss that message. Wait, what do you mean? I read this message. I read that message aloud. I don't... I don't know what else you want me to say. I mean, like, that was when I read that one aloud. I totally did. Okay, maybe I didn't look. I'm sorry. What do you want me to say? I'm not gonna like. I can go back to the. Maybe I didn't read it aloud, but I totally read it, which is why I mentioned that I had read the rest of this. You know, like. I don't know what you want me to say. Like, I mean, at some point, it just doesn't make sense for me to read every single message that comes into chat. So I don't. Sometimes I just comment on the message. And sometimes I read it aloud. It just kind of depends, you know? I did read the, yeah, I definitely read that one aloud. And then I covered that one extensively. And then I read this one aloud. And then I explained why. Yeah, whatever. It's cool. Doesn't matter. Okay, so we're going to go over here. Right now, unfortunately, Klima only works with Julia 1.3. So we're going to run Julia 1.3 double dash project over here. And let's go ahead and figure out or show the error. So the first thing I'm going to do is I'm going to go into VI source arrays, and then we're going to go into MPI state arrays .jl, And we're going to go to the reshape function we wrote yesterday. Reshape. So I'm going to comment this reshape function out right now, and I'll show you what the error is as it currently stands. And let me do this here. Now, I don't know if you can comment inside of a comment like that, so maybe... Oh, let's just see what happens. So we're going to do using Klima, and let's see if this precompiles, and we'll go from there. I'm just a bit frustrated that nobody reacted my... Wait, what do you mean nobody... I literally read that aloud. I said I need to refactor my script again so that the data it needs from the JSON file instead of a bunch of hard-coded if statement checks. I know I said that one aloud. Like you can't keep saying I'm not saying things aloud. I definitely read that one out. And I said that it sucks or something like that afterwards. Or good luck, man, I think is what I actually said, which I know is admittedly not like the best reaction, but you know. So I don't know. Like, sorry, I'm not trying to be like, I'm not trying to be like super like antagonistic or something like that, but I'm like 90% sure I did, you know. Anyway, that sounds kind of bad. Why is this taking so long to precompile? What do you think of autodidacts? I don't know what those are. I feel like I should. I feel like I've heard the word before, but I don't remember what it means. An autodidact is a a self-taught person. I think that when it comes to programming, almost everyone's self-taught. So I think that's fair. I'm sorry for apologizing all the time for running my stream. Yeah, that's hello, welcome to Simuleos. That's the nature of this stream. There was some guy who basically invented a I don't remember who it was, but someone sent me a message on Twitter, or maybe it was here on Twitch or something, and they gave me a list of or they gave me like this comic of the superhero who just like broke through a wall, and then, you know, immediately just apologized, like, oh, I'm so sorry, I shouldn't have done that. And then he looks over to the door and he sees that it was there. It's like, I really should have just used the door. I'm really sorry about that. And like, that was the superhero that was like embodying my presentation style here on stream. I just consistently apologize for everything that I'm doing. Let me go into VI test, and then we're going to do arrays, and then we should have one for reshape.jl. And what I'm going to do is I'm going to show you this error. So we're going to just grab all these lines in here. And then once we have it all done, we'll do the reshape. I forgot to do using... Wait, what? What do you mean MPI not defined? Oh, I just didn't grab that line because I'm an idiot. There we go. So now I'm going to define Q here. Grab that. And then I'm going to define a reshape of Q here. Okay. So what I just did is I defined no method matching reshape. What? But I thought I just... That's not the error I was expecting. Maybe I can pull it up in master. So let's do git stash, and then we'll do git checkout master, and let's just do the same thing we just did. Julia double dash project. Let's just grab these lines, and then I can show you the error there. And then I'll show you the fix that we did to it. Let's see. Self-taught is a terrible term. It's completely discarding all the help from peers and tutorials and documentation and stuff. Right. But also, I don't know what term you would say for, like, those who have been taught, I don't know, who were taught outside of a standard educational system. I'll try to pay more attention to the stream. Maybe it's just me. No, I mean, I'm sorry. I feel like I was being very, like, aggressive, and I didn't mean to be aggressive there. Hacker Man, I'm very far from a hacker man. Hey, Geek Panther, how are you? Maybe someone should watch it back later to check. Feel free, you could. You commented out. Right, I did comment it out. But there should be a reshape that is already in Julia's abstract array that it should have called on. Let's see. I don't like the aesthetic of calling it something passive like using module as opposed to import module. Sorry. Hardly Difficult, thank you so much for the raid. If you guys haven't seen Hardly Difficult before, we've raided him a few times after stream. He's a wonderful programming streamer. What were you working on today, man? I hope the stream was successful and useful. And for those of you who may be coming in for the first time, let me create an error, and then I'll explain the error, and we can talk about... Oh, you know what? No, I don't know what. Why is this doing something different than what it was doing last time? Okay, well, let's just go back to the branch we had it on, and we'll talk about the error we're currently having. Whatever. JRS, what am I looking for here? MPI reshape. Okay, whatever. So we're on Julia 1.3 double dash project, and we're just going to include this file, which is going to be test arrays, and then we're going to do reshape.jl. Cool. Okay, so let's talk about what we're doing. Since I already wrote it out and we're waiting on the code to run anyway. So for my work, what I normally do is I work on this code base called Klima, which is the climate machine. Right now, I'm working on a particular subset of Klima so that we can basically access data appropriately on a GPU, right? So this code base works in Julia. It targets multiple GPUs, which means you have to use MPI to communicate across these GPUs. Now, in particular, the type of array that we create to allow for this communication is called an MPI state array. Okay? Now, the issue is when we try to reshape an MPI state array, even though it has an array or coup-array backend, we're not able to actually access or manipulate elements of this reshaped array. And this is simply because when we do the reshape function, it returns a type of reshaped array, MPI state array, and we just want it to return MPI state array, right? So we have to write our own reshape function to do that. Reading documentation is not the same as having a teacher. You are your own teacher in that instance, i.e. self-taught. Let's see. I taught myself how to play guitar, which was a bad decision because I didn't know how to play it. So I was a crappy teacher. That might happen, but you'd still be self-taught. As far as the learning guitar thing is concerned, I tend to feel that in some ways you are your own best teacher because you know the ways that you learn best, right? Like, so sometimes you can learn better just by grabbing a bunch of books and reading, for example, in programming, than you can if a teacher tells you how to do things, right? For some people, that's not true, but for some people it is. Mehi, 2017, thank you so much for following. Really appreciate it. I learned C from reading different languages. Let's see. Different strokes for different folks, right? Fun fact, Paul McCartney learned to play the guitar in the mirror, which is why he plays it with the wrong-handedness. Oh, really? The education system does not teach you programming. At best, it gets you interested in teaching yourself on top of the curriculum. Kind of agree with that. Program consistently gives the same error. Why? Program now gives a new error. Why? I was expecting a different error, but it's okay. We have something that works. Let me see if it dropped Q into the REPL. It did. Okay. And we should also have QB. Okay. So what is this code doing? So it does a couple different things, right? So first we use MPI, use Klima MPI state arrays. Again, that's just how we're holding the data. We initialize Klima, still fine. Everything's still fine. Then we have constant array type, which is just going to be array or coup-array, depending on whether you're on the CPU or the GPU. And we initialize MPI by giving it some sort of communication world. We have a floating type, which here I'm just setting as floating type 32 for the test. It doesn't really matter too much. And then we have Q as MPI state array of floating type, right? And we have MPI communication, and then we have our reshape function here, QB. Okay? Now again, this reshape function should return an MPI state array. But what it actually returns is type of QB. Right now, it returns an array. And this is because the way I wrote the reshape function, it basically reads in an MPI state array, casts it onto an array to call the native Julia functionality. So I'm going to modify that function a bit, and today's stream is basically going to be focused on making this reshape return an MPI state array, not an array. And that's the whole stream today. It sounds like it's really down in the weeds. It is kind of down in the weeds, but I'm hoping you guys will enjoy it just the same. And again, if you guys have any questions or anything like that, feel free to let me know. At worst, and I think that is more common, those who come out of a programming curriculum able to actually program likely knew how to program before they even started it. It will teach you the self-impression. It will teach you the self-impression of being a taught programmer, and useless one at that, with the self-image of being superior to any of those self-taught fools who couldn't even muster to get through a single BS course. I mean, I have a PhD, right? Like, and so I've gone through the curriculum, maybe not exactly the full computer science curriculum. I was more computational science. But I definitely did, the PhD, and I don't have that impression at all. I feel like people who are self-taught is pretty cool. What's the climate machine? It's klima.caltech.edu right here. It's just a way to simulate the climate. That's what we're doing. Let's see. Let's see. Do you ever nerf your code? I don't know what that means. I actually think that is doable if you claimed the same C++ though. So you have a GPU locally at your home, or are you connected to a remote machine? It is here. So GPU is a graphics processing unit. It's the thing on your computer that basically displays the graphics on your machine. Really good for computation for various reasons. A teacher in my cases is really just a mentor, and having mentors is often very useful. I could agree with that. I'm skeptical of anyone claiming they know C++. I'd be surprised even if the people on the standards committee knows 100% of it. Are you allowed to stream your work? I asked everyone. They said it was cool, so I should be okay. What are you developing? The climate machine. That's what we're developing. It's just a climate thing. Didn't Bjarn say that he estimates he knows like 60% of C++? Are you at MIT now? I mean, I work for MIT, but I'm in Alabama. Let's see. So did I. Hey, everyone. Let's see. Thank you. Let's see. Hi. I've been at Prague meeting. Wait, I've been at the Prague meeting in February. Cool. I mean, what's the GPU? Oh, it's unfortunately I just have a 970. It's fine for development, but it doesn't have the latest features. Sorry, I misunderstood that, Geek Panther. Okay. Yeah, I was thinking like, why are you asking me? Yeah, okay. I was asking you. I was wondering why you were asking me that question because I thought it was kind of. I thought you would know. Okay. So let's go back to that reshape function and let's just mess around with it a bit. Let's go into vi source arrays. MPI state arrays. By the way, I don't know if I said hi to everyone, but hi. I hope you're all having a great day. So let's go down to reshape here. Right, and so what I'm going to do is I'm going to check to see if this works. So I don't have to read in a type. This is just a simple thing, but it would help if I was able to do this. So let's go into test arrays, and let's just see if this runs. Unfortunately, I'm going to have to rerun it like this. It's going to take a while. Are you having a great day? It's okay. It's a day. It's a day. It's not like a great day, but it's a day. Thanks for inspiring me. Hey, I'm hoping that, yeah, I'm glad that you're happy to program or you're willing to do more complicated things now than you were before. Like, I'm happy to help is, I guess, what I'm trying to say. Okay. If you try a bit harder, maybe you might even give me good ideas. Oh, fair enough. Let's see. Then I hope you have a day. Yeah, I mean, that's about as much as you can hope for me at this point. Having a day is just about what you can hope for. Okay, so I'm going to see if this runs. If it runs, I'm pretty happy. Ponder is buying an SUV and nicknaming it the Climate Machine. Oh, see, that was... okay, you're right. I'm sorry that I inspired you to do that. That's, yeah, the SUV probably... Yeah, okay. I'm sorry about that. Okay, so it seems to do the same thing as it did before. So that's good. And now let's go into MPI state arrays and let's look at the reshape function here. Okay, so as of yesterday, we kind of went through and we targeted the reshape function in Julia. And in doing so, we found out that Julia's reshape is essentially this C call to a JL_reshape_array of some array with some floating type n, and then any array, whatever. So what we need to do is we need to modify this call so it works with MPI state arrays, and I'm just gonna mess around with it and see what we can do. I'm a convinced cyclist and even own a driver's license. Actually, as far as cycling is concerned, so yesterday, just before stream, we went shopping. You know, my family, my parents and I went shopping. I'm currently at my parents' place just because I wanted to get out of Boston. And in the process, I picked up my unicycle from the storage unit. So I have my unicycle. I'm trying to learn it, and I kind of want to be able to unicycle around Boston. It's something I want to try to do, but we'll see how that goes. So let's go ahead and take a look at this C code in here, and the best way to do that is to open up the Julia source. So let's just go over here, open it up in huge. And also, guys, if this isn't your cup of tea, I will be doing my normal algorithm archive stream at 6 o'clock p.m. EST. That's in about an hour and 20 minutes or so. So we'll be doing both streams today. So if you're, if this isn't exactly your cup of tea, totally understand. Hopefully I'll see you around for the algorithm archive stuff as well. And also, sorry about the stream times for people in Europe. I realize that later streams are hard for people to attend if they're in Europe, but I can't really do too much about that, you know? Let's see. any other people who can concentrate better when they have other people talk to in the background. I feel like, I mean, I'm doing this stream, so I feel like I actually get more done sometimes on stream than I do off. Will unicycle for food? Oh boy. I don't think I'd ever be able to get good enough to do that. Old man Professor Schloss, unicycling to work. When did you move from Okinawa? I left Okinawa December 30th, 2019. And I started my job in MIT January 6th. Totally not admitting that I'm not paying attention to the stream, just using it to concentrate better. That's totally fair. I totally understand. CD builds, and we're going to go into Julia. Okay, now I don't remember what I did last time, but I'm sure it was in my history, so let's do history. grep. And I'm going to grep. Ah, dang it. And let's see, so I just did 223. Okay, and we're going to go into vi source, and I believe it's array.c. I probably should have waited for the autocomplete to finish, or the grep to finish. Or maybe I should just Control C out of that, and we just do vi source, and then array.c. And we should be able to find JL underscore reshape in here. Here it is. So here's the function that we're calling with that C call. Right. So as you can see, it takes in some sort of JL value T, which is the type of the array. And then it takes data, and then it also takes the dimensions. Now, this is very difficult for me to understand, and it's also not particularly commented. So, yeah, this isn't going to be the easiest code for me to get through. And it's also kind of long. Crap. Okay, but I believe that's the end of it. So I guess we have a couple different options that we could go with. We could try to understand the C code a bit more. We could just try randomly using the C call with MPI state arrays. I could also use a bunch of other things as well. I wasn't talking about like IDEs and stuff helping me out here. That wasn't an IDE wouldn't help me here, is what I think. Because it's like the logic of it that I don't understand. Like, for example, I don't understand, so JL underscore array underscore T, I don't, like, yeah, there's just stuff in here that I haven't, this is the first time I'm opening it, right? And it's got a whole bunch of these, like, weird things, like, that are just generated all over the place. Unicycles, aka compound fracture generators, those things are lethal. Yeah, maybe I shouldn't, I don't know. The issue is that sometimes a sentence sparks my interest, which distracts a little, so I don't know if it's better overall. Don't worry about your stream times. I absolutely enjoyed watching your Easter algorithm streams with one eye, while the other one was tracking the full moon. Let's see. This is why people use IDs. Hey, Carlos Spy, how are you? Let's see. He is using an ID. It's just sad that he's not using Emacs as an OS beneath it. I actually saw someone at MIT who was basically using Emacs as an operating system. It was really cool. Like, I was a big fan. Carlos Spy 81 and Legacy 205. Thank you guys so much for following. Really appreciate it. Let's see. He is using an ID. Are you going to comment on everything here and unit test everything like in OIST? Probably not so much. I will. I mean, this is the Julia source code. I can't just like. I don't know. I can't just like redo everything in the Julia source code. I'm doing my best to like help out with the documentation where I can. And I think we are making good progress there, but there's only so much you can do, you know, when you're in a group of like 20 people. Have you considered tasting Rust to crunch numbers? Yeah, so I think Julia is faster than Rust on average, but I don't know. I'm not going to pretend I know. All I know is that Julia is about the same speed as C, and I thought that Rust was about the same speed as C. But also Julia's GPU interface is by far one of the easiest GPU interfaces I've seen. It's really, really quite nice. Okay. Give it to a PhD student, like everyone else would. Yeah, maybe that's why I had to do it. So I think what I'm going to do is I'm going to actually look at the source code for what happens when we reshape a non-Q array, or when we reshape a, well, let me just mess around a bit. Let's go back here. Let me change this C call to take in, instead of array of ftn, we can probably just read in array type, I would imagine. So maybe we can just do array type, I imagine. And then if we do array type in here as well, maybe this will work. And then maybe we can do array type of A. I don't know. I don't think this is gonna work, but we can give it a go. The Julia 1.3 project. This will solve at least one issue if it does work, but I'm 90% sure it won't. So we'll just kind of mess around with it a bit. My main issue is, like, I was expecting the reshape function to be written in Julia, and the fact that it wasn't I'm now a bit confused as to what all of this does. So let's see if we can figure out where array type is defined. It should be, here it is. Yep. Okay, so it's not defined. Okay, so let's just read in array type. I guess it's gonna be, we have the FT. Yeah, but we don't know array type. Let's just read in array type. Whatever. I think it should be type. Oh, I just had it 2 seconds ago. Get diff. Yeah, get diff should do it. Let's see, type FT. So we'll do type array type, and then we'll do where that FT and array type. And we'll just read in the array type to the test. And again, we'll modify this later, but this is just what I'm going to do for now. So we'll do reshape, and then here we should be able to read in the array type. And let's just see what happens if we do include here. I imagine the precompile will work, but I imagine the reshape won't. Let's see. Still unconvinced of Rust. I'm also unconvinced of Rust. Too bad Doxygen seems to be dying. What's your thoughts on CUDA C++? I like using CUDA C++. Is what I use for my entire PhD. I'm a big fan. Let me just get this call to work. Quite frankly, the only reason we're using Julia now is because, I mean, it's slightly easier to use. Slightly easier to use Julia than it is CUDA C++ for GPU stuff. But I'm not going to pretend that I don't like C or C++ anymore. I still do. The cycle of throwing heavy lifting to postgrads. Yeah, Java has one nice thing. You can compile stuff while running and inject it into the current process, no problem. Oh, interesting. I don't know if that's one of those things that I kind of feel like might not be. Let's see. I'm not going to learn another language. I know enough ATM. I've never claimed I know enough ASM. Right, assembly. What's a ... That should be a splatting operator. I don't know where you see it on screen. Oh, here it is, up here. Real indices. So the ... is a splatting operator. It takes the operators and outputs them all. So it's like a set of different arguments. So like if your function takes A, B, and C, and you have an array that has A, B, and C inside of it, splatting will just pop them out of that. I think the ... at the bottom of the window. Oh, never mind. I was wrong. This is just a comment. It's a multi-line comment. Some people in Julia use multi-line comments as strings. I don't particularly like doing that, but okay, coarrays.coarray, that's fine. But I was hoping it would give me. Can I do array type of the following? FT. Okay, that seems to work okay. So if I go in here and I try this C call, and let me just do array type of ftn like I had before. And we'll do ftn also here. In principle, that should be what I need. Let's run that. Control D, try recompiling it. Again, I'm just doing a bunch of tests here. All I'm trying to do right now is make it so the reshaped array, the output array, this time is now a coarray instead of a normal array. And if I'm able to do that, darn, that's not. What if I change this to, okay, let me just, I know this is going to be on the GPU for now. So let me just yank, let me just yank and paste that. Comment this guy out. And let's just see what happens if we do coarray here. And put another coarray here. And I guess, I don't know if coarray of this is defined, but I'm going to put it in there, pretend it is defined. Include here, and let's see if that works. Yes, both of those are multi-line comments. Let's see. Well, you're right. One is a multi-line string, but it's treated as a multi-line comment. But just like Python, if it isn't saved, it becomes a no operation, essentially a comment. Right. Bebin, sir, hello, how are you? Sorry for asking stupid questions, trying to make heads and tails of this. No, I appreciate it. Thanks so much. It's funny your shell has more colors than your editor. Yeah, that's how it always is for me. I don't use syntax highlighting on my code. I realize, yeah, that makes some people in stream not like it, but it is what it is. Coup array not defined. Okay. Well, just again, we'll fix this later. But I'm just kind of getting something working for now. That's my main goal today, just to get something working. And we'll just see where it goes, you know? Worst case scenario, we don't have anything working by the end of stream, and I'm just going to have to just talk to the creator of MPI state arrays and be like, yo, dog, I can't for the life of me figure out how to do a reshape, which sounds really sad because it's a trivial operation, but at the same time, it's not super trivial. Like, it's one of the things that sounds trivial but isn't. Let me get some more water. Oh, I can't even change my chat color anymore. Whoa, that was a segmentation fault. Probably because we don't have a coup. Okay, let's just mess around here a bit. Okay, let's go to reshape. Let's see what we can do. I'm gonna return back to this C call. X there. Oh no. Just neither of these worked. So maybe I just delete that one and I do that. And let's just do Julia 1.3 double dash project and we include. Let that compile and then I'll just mess around with the MPI state arrays and see what we can do. The chat is on the right of the screen. Yep, that's the chat. What suggestion could you add to build a nice and organized code base and implement numeric algorithms? For example, what kind of design patterns do you prefer in scientific coding? That's some next level ricing. Okay, so honestly, I'd never heard the term ricing until people mentioned it here on stream. I'm sure this is when I hit the pink chat, right? I don't know how you guys have so many clips. Like, you just keep everything clipped. But yeah. Okay. As far as like design patterns and stuff like that, as long as everything's tested and everything is, well documented, I don't care how you do the documentation or how you do the testing. The main thing is with scientific computing, people tend to just ignore essential parts of the software development practice. Again, documentation and testing. As long as you have both of those, you're probably going to be fine. Okay, so let's go up here to the top. So now we should have Q and QB available along with array type available in the Julia REPL. Cool. Okay. So I'm going to mess around and we're just going to see what we can do. Are you running BSD or? Oh no, what is this? I don't know what this is. I feel like I've said something really bad at one point. Linux from scratch, do you also like BDSM? What is BDS? Is that a... Oh. I'm sorry. Right. So, oh man, we've had some weird comments on this stream. Bible Day study meeting. It is an OS, it seems. Gromax is the best developed piece of software. What? In the world? Not even Anyway, let's keep going. So we have everything out in the Julia REPL now, and we can mess around with it a bit. And we'll just see what we can do with it. This is my favorite clip. Oh no. What is this clip? Is this the one where you sent me the... what is this one? This is... Oh, when I consistently messed your... Maybe we should put an underscore in there? Something like that? Alright. This is an ASCII New Year animation. It's going to be public, of course, initialized with a readme. Git ignore file, what should we ignore? We should ignore, I'm so sorry. It's like how you try to read around the spelling mistakes. I'm so sorry. The joke is that, like, for some reason, when I'm reading chat, I don't know how, but I always miss Gathros's comments. And it's not intentional in the least. I just miss the comments. And I've been doing better. I've been trying to do better, but I just, every time, like every stream, there's always one comment from Gathros that I just miss, and I'm so sorry. I still don't get how it's a running joke. It's my bad. I'm so sorry. Honestly, like I really appreciate all the help. Like I still use your GathVL library like regularly for animations and such. So I like, obviously I appreciate it. You missed 3 comments at the start at 5:26. 5:26. Let's go back. It's probably one of those things that I read but I didn't say out loud. 3:26. The only messages he misses are mine. What's the next one? Colonel Canada and you said there was one more I missed. Well, Symbiote Cow, but I don't think. Let's see. You're right. I did miss the only messages he missed are mine. Why am I so bad at this? From what I've learned, the sword icon in front means that they have been cut off before because their messages aren't important. No, that's not what it means at all. I obviously trust Gathros enough to be a moderator for the chat. So, man, how you're right. I missed a message. How did I do that? Okay, anyway, let's keep going. So what do we have then? This returns an array. What I'm going to do next, it will never end. It might end one day. From what I've learned, okay. So, what I'm going to do is I'm going to go ahead and create A, and A is going to be just ones of 100, 100, 100. Actually, ones will be like ones of 10, 10, 10, smaller. We're going to say B is going to be a coup array of A, using coup arrays. And now we're going to show some of the most convoluted code I've ever seen in Julia, and I say that every single time I edit anything in Julia, but here we go. Let's go ahead and do B. It's going to be equal to coup array of A, and then we're going to do @edit reshape B. That's too many zeros. Do that. Okay. So here's the source code for reshaping a coup array. Let's go and make this huge, and we'll just mess around with it over here. There you go. Something like that should be fine. Let me move this up just a bit so you can see the whole terminal. There you go. Okay. And let's just figure it out. That's what we'll do. One day you'll miss all messages on a stream. Maybe. Well, on that stream, I probably just wouldn't have chat. Okay. So, reshape. So this is what happens. When you call reshape of an abstract array, dimensions dims, it will call underscore reshape parent dim. So where is that defined? Underscore reshape. It's defined there. It's being used there. Inline function underscore, nope, that's not it. Reshape parent vector here. So it's probably defined somewhere in here, right? So function reshape v abstract vector. The one we're looking for is probably function reshape parent abstract array dimensions dims. Okay. So what does this do? It does n is equal to length of parent. Product is dimensions equal n, or throw DMRS. So this is just throwing errors if you're not able to reshape. And then it calls double underscore reshape. So let's look for underscore underscore reshape. And that's defined here. Okay. So what does this do? So it says P of a tuple of an abstract array, index Cartesian, dimensions dims. Parent is P1. strds is equal to front. Ooh, boy. strds1 is equal to map for resizing empty arrays. And then we have reshaped array, parent dims reverse mi. Okay. So where is this reshaped array type defined? Probably at the start of the file, I would guess. Reshaped array type is defined here. Or struct, I guess. And it takes in a parent abstract array T, dimensions of an n tuple, and then mi, and I don't know what mi means. There's a lot of stuff here that I feel like we need to I just don't understand. Did you remove the bar at the bottom of the screen? No, actually, the issue is that my current monitor, so you're talking about, so here's my mouse, and you can't see it now. It's actually under, there's stuff under here that you can't see. My monitor resolution, is 16 by 10, but I can only stream at 16 by 9. So there's like a tenth of the screen down here that you can't see. The Art of DHT, thank you so much for following, really appreciate it. As I like to say, whenever gaining such an icon, thank you very much for trust well misplaced. Wait, but I assume not everyone rolled CE for their alignment. What is C? Oh, chaotic evil. Oh, right. Can I get this on GitHub? You sure can. GitHub.com/climate machine klima. Here we go. Here is the latest whatever. Yeah, I didn't realize it was 16 by 10 when I picked it up. So had I known that, probably you wouldn't have picked up a 16 by 10 display. But it is what it is. Okay. So the struct reshaped array will then have a parent p, dimensions n tuple n int. Okay, cool. So this is what I'd expect. Does this mean that anytime we reshape anything that is an abstract array, it will return a type of reshaped array? That's not true. Because if we let this command finish, b, let's just do a reshape here, and then just run type of this, we'll get coarray, right? So this is the type of reshape we want. We want it to be that when we reshape the array, it returns back a coarray. This returns coarray of float64 2, coarray float64 3. No, that's weird. So what's happening here is we have a coarray of float64 2, coarray, float64 3, nothing. So here's the original array we had. Coarray float64 3, nothing. If I just do type of b, we get coarray float64 3, nothing. So what happens if we do a reshape of a reshape of a reshape? Let's do reshape this guy back to the 3D array. So we'll do this. I think this is right. Ah, dang, I missed parentheses. Okay, so now it's a coarray. Float64 3, coarray float64 2, coarray float64 3, nothing. There's our issue. Right there. If we do a reshape, instead of B, but instead do A, it will just return an array of float64 3. Okay, so that's the issue right there, because the people, again, rather impressive people who developed the GPU libraries for Julia, do not allow for you. So what happens if I try? So let's just say C is going to be equal to this. So let's say C is going to be equal to that. Ah, I forgot an equal sign. Okay, so now we have C. Let's just try doing C of 1. Ah, that works. So my understanding was the issue with doing this with MPI state arrays. Let me do type of QB. Ah, of course it's an array, because I cast it onto an array. Okay. Let me think here a bit. So the issue with doing the reshape and accessing elements inside of a reshape is that, how do I put this? There's basically a level of like recursion depth. It's not really recursion depth, but for a type that complicated, you can't access the inner elements. That's our issue, right? And the issue happens to be that when you reshape an array, it returns just a reshaped array. That's what we saw earlier with C. So if we do type of C here, where did what? C? What? Oh, that's because it's A. Okay, so let's do B, and let's do C of 1. Oh, I'm an idiot. That's the error I was looking for. Nice. Okay, but if I do B of 1, oh, no, that doesn't work either. Type of B. Why does that not work? It's just a coarray, right? Am I never able to do that on a coarray? Maybe not. Maybe that's the issue. But I can broadcast. So if I say B of, okay, let's try this. B of 1 to 10. That'll work. So B of 1 to 1 will work. So what if C, does C of 1 to 1 work? What a weird thing. What a weird thing. Okay. So what's the third parameter on the type? So it's float64, which is the floating type. 1, which is the number of elements. And then nothing would be whatever MI stands for. And I don't know what that stands for. All I know is that it was in the struct for the reshaped array as well. So message interface, maybe? I'm not really sure. But if you reshape, so if we do type of C, the third argument is always going to be the array of the parent. B1 is a scalar. Yes, B1 is a scalar. That is correct. I swear I was able to do this the other day. Am I just on a weird Julia version? Oh, let me try running this in just Julia, not Julia 1.3, just normal Julia, which should be 1.5. So let's do using coup arrays. Oh, hello, that's not how you spell it. Using coup arrays. And we'll just do this whole thing again in just Julia 1.5. This is actually, when I say normal Julia, this is not, the only way to get this version of Julia is if you compile it yourself. So we'll say A is going to equal to 1s of 10, 10, 10. B is going to equal to coup array of A. And C is going to be equal to reshape of reshape of reshape of B. Okay, so now let's do B of 1. That works. C of 1. Again, it works. Okay, let me try something really quick. So the reason we have to use Julia 1.3 is because we have a dependency on kernel abstractions that only works on 1.3. So if I use the master branch of that, where this bug is fixed, in principle, I can use a later version of Julia. And I'm going to try rerunning the test on a later version of Julia where we are allowed, where we don't get the scalar get index is disallowed. We just have this other performing scalar operations warning, which, you know, I'll take warnings, but not errors. So if we do include test array reshaped array.jl, this one should pass just fine. We shouldn't have any problems with this running. So this should run. And then if it runs, I'm going to modify the code, and I'm going to see if it runs elsewhere. What is A? What is B? What gave you an error when you put A or B parameters? Right, so A is my array, so it's my CPU array. B is my GPU array. And when I tried to access a single element of B, I was provided an error. Now, the reason for that makes a lot of sense if you're used to GPU computing. Essentially, the way that the data is allocated, or the data is put onto the GPU, it's put onto the GPU threadwise, right? So this is to say that like every single element in B kind of has its own thread that's dealing with that element, right? And it's very rare, if ever, that you're going to have to grab a single element of B in this way. So iterating through B just doesn't make sense, which is why you get the error scalar get index is disallowed. What that literally means is grabbing a scalar, grabbing an individual value from this array is not allowed. Now you will see this error also with broadcasting, because sometimes in order to broadcast, it will have to take each individual scalar, that is to say each individual element out of the array, in order to do like multiplications or something like that between arrays. And so that's why you get scalar get index is disallowed for that kind of stuff as well. My understanding. Again, if someone wants to correct me, feel free to correct me, but that's my current understanding. So what we're trying to do is we're trying to get around that. In particular, we're trying to make it so we can reshape a coup array and access the elements on the inside without any problems. Now let me just let this run and make sure this currently runs without any errors, and it seems like it does. So now I'm going to control D out of here, go to VI source, arrays, MPI state arrays, .jl, and I'm going to remove the reshape function and just let Julia naturally deal with reshape. We're just gonna let Julia do it. It should be able to do it. I don't see any reason why it wouldn't be able to do it. So now we're going to Julia -- project, and we should be able to include the test and see what fails. With any luck, this will actually pass, which would be somewhat surprising. Which would mean that the way that we fix this error, is by essentially just upgrading Julia versions, which would be great. That's the easiest solution ever. I know I wasted 3 hours on stream on this issue, but if the solution is just to upgrade your Julia version, that is the best solution, right? It sucks that I wasted time on it, but hey, it is what it is. So we're going to let this run. Again, if you guys have any further comments, questions, concerns about any of this kind of stuff, I know it's confusing. See, I wasn't getting that error yesterday. I was able to reshape. Just fine. An MPI state array. Did I change the code somehow? Um, let's just control D out of here. Git log, adding function to reshape an MPI state array, updating MPI reshape to master. Okay, so what if I do git diff of, oh, I don't know. Can I just grab this commit hash? I think so. Oh, that's not exactly what I was looking for. Right. Yeah, this is all just right. Okay, here we go. Base reshape. Yeah, I added all that. I know that. MPI state array 444. FT is float 32. Reshape. Aha! I see the problem. VI test. Arrays. Reshape.jl. It's because this reshape has a slightly different function argument or function call. Okay, so let's do Julia double dash project, and let's try running that one more time. Confusing? No, it's confusing. I have no doubt that this is confusing. This type of stuff is incredibly confusing. Also, like I'm building this for a climate simulation, but I'm so far away from the climate and physics and all that kind of stuff. It's not even obvious how we get from here to there. I am trying to connect it so that you guys can see the parts. And again, because I have experience in GPU computing, I tend to do more of the lower level stuff, which I tend to like. But it is true that this isn't quite related. Scalar get index is disallowed. Yep, that's the error I was expecting. Yep, okay, good. So at least we still have an error in later Julia versions. So why... Wait, what? I'm gonna do something dumb here. I'm gonna actually just use my normal set of packages. So we're gonna do using MPI. Oh, that's MPIT. Just to make sure I have it. I do not. So let's do add MPI. I'm just gonna use my normal set of packages. I'm not gonna use the set of packages provided by Klima. I'm just gonna use my own set. And the reason I want to do this is because we were just able to get around the scalar get index is disallowed thing a second ago. So in principle, we can also get around it here. Now, the big issue is that in order to... the big issue is that... Okay, I think what I'm going to do is I'm going to see if this works. If it works, I'm happy. If it doesn't work, it doesn't matter because I still have to do... Like, no matter what, my next step is the same. I'm just going to test to see if this works. I think I need to rethink how we're doing this reshape. Okay, let's see how this goes. So we're going to do include test arrays reshape, and let's just see what happens. I'm surprised this is working at all, honestly, because I haven't run dev Klima in a while, so. Cool. And again, guys, if you have any questions, comments, concerns, anything like that, just let me know, and I'll do what I can to answer it as soon as I see it. Need some more water. I'll be doing the Klima stream for about another 45 minutes, and then I will move on to the Algorithm Archive stream, where I do discussions about iterative function systems, fractals, all that kind of stuff. So, again, if this kind of lower level Julia stuff isn't exactly your cup of tea, then feel free to join me there. Although I do think this is also very interesting, so I hope that you guys do too. Meowcat, so updating versions didn't help. I don't think it helped, but I'm not sure yet. We're trying to decide that now, so we'll figure it out in like a minute as soon as this guy precompiles and we have all the issues. Basically, if this provides an error, then no, upgrading versions did not help. Admittedly, maybe if I just upgraded to 1.4 instead of 1.5, maybe, but we'll just let it run and we'll see what it provides. The biggest issue with developing Klima right now is that you have to recompile it every time, pre-compile it every time, which just takes time. But it's okay. It is what it is. Let me go over here really quick. I got some messages on other things to work on. Cool. I have more work to do. Great. Yeah, okay, scalar get index is disallowed. Updating did not help. Cool. Okay, well that's in some ways good, because that means that all of the work that we did recently isn't for naught. There's still something to be gained from all of that. Okay, so what do I need to do then? I'm going to try to look in the code, and we're going to try to find a new way to do this reshape. So let's go to vi source, arrays, and then we're going to go to npi state arrays.jl. I figured it out. Because the specific heat capacity of water is so high, you pump all the water into space, and pump it back, and then drop the ice blocks from orbit. Huh. You know what? I never thought about that. Honestly, this might be one of the... How do I put this? That's an idea. I'm going to go as far as to say that is an idea that I never thought of before. And that's pretty cool. You know, sometimes people think of ideas that other people just don't think of. That's the beauty of being a human. I'm not going to say it's a good idea, but like, you know, it's an idea. I don't know. I have no idea. I figure that the heat used to pump the ice into space is going to be well and beyond any of the heat you lose when you bring the ice back. Also, unless you could somehow find a way to have the internal combustion like inside the ice, which will then cool down outside. I don't know. Is this Julia? Yeah, this is Julia code. Okay. So let's take a look at the MPI state array. So this I have no idea what this stands for. Dat-N, die1, DAV, buff. I wish we had documentation, but we don't for this. Okay. So let's go down to the reshape. So what we've learned today, so this reshape function was basically pulled from the reshape function already naturally in Julia. This particular function, what it will do is it just throws an error if your dimensions are mismatched. Which is what throw DMRSA does. And then it does a C call to JL underscore reshape underscore array, which is C code that is used to reshape. This code right now does what we expect it to do. It actually does provide a reshaped MPI state array. However, it casts it onto an array, which isn't good. When we tried to rewrite this so that we could cast it onto a Q array, we couldn't figure out how to do that because anytime you reshape a Q array, it actually returns a reshaped Q array. That is to say, the type is different than what we want it to be. So if I'm going to do this, maybe what we need to do, all we need to do is we need to change the way in which we access elements on the MPI state array. The data isn't going to move, right? It's just the way we access that data is. So, and if we were using linear indexing, none of this would be a problem, but we're not. So, what if that's the solution? What if the solution is to change all of the MPI state arrays so that it uses linear indexing instead of Cartesian indexing? That's an idea. I was just thinking about space elevator. Then you were streaming about climate. So, yeah, I don't know exactly how space elevators work. Well, the state of documentation is better than SSH manager, which is Julia base functionality. I don't even know what SSH manager is, but yeah, I would agree with you that a lot of Julia documentation is lacking. Hopefully it'll get better, but it is lacking. Okay, so let's just look at the functions that we have right now. Make some more water. And let's see what we got. Okay. So we've defined all of these base.similar. Let's see, base.similar. MPI state array here. Okay. Oh, here's the definition of all those guys. VMAP rec C is an ordered array of elements to be received from the neighboring MPI arrays. Okay, fair enough. Are you in the Julia Slack? I am in the Julia Slack. Base.similar. Let's see, base.similar. Base.similar. Base.size, base.getIndex, base.setIndex. And every time you're doing getIndex or setIndex, all you're doing is q.realData. And then you're just using like the default get and set indices there. Let's see, base.ltype. So maybe so just make a wrapper on MPI state arrays that converts Cartesian to linear access and have reshape just change the wrapper. Right, that's kind of what I'm thinking. If MPI state arrays were already written such that everything was linear, right? So it's it's all accessed 1 to 10, not x comma y comma z. It's just one big chunk of memory. Then it would be easier to access the elements and also easier to manipulate the elements because we could just set a Cartesian index when we want to set the Cartesian index. Okay, so base.get index and get index here just uses q.realData. Now what does real data do? Is that what we want? Real data is going to be... Well, actually, do we have this up in Julia already? Maybe, let me check my Julia shell. No, that's not... No, do I have Julia shell open? I do not. Okay, so let's go into MPI state arrays. Let's look for reshape here. It gave us a scalar get index is not allowed. I know what I need to do. Okay, Q here. And let's just do, go into the test, vi test arrays, MPI state arrays. I'm sorry, reshape.jl. And I'm going to comment out this test that provides an error. And now we're going to run Julia again. Where are we? Julia 1.3. I'll use 1.3 again. And then we'll just read the test in. So this shouldn't provide an error because we're never accessing the elements that will provide the error. And then I'm just going to mess around with the types and see what we can do. Because I think maybe what we've done is already wrapped it. And if we've already wrapped it, then that solution's out the window, right? In fact, I think that's what the type reshaped array is. It's just a wrapper on top of... Anyway, we'll just see what we get, and then we'll try to figure out those types afterwards. This stuff isn't trivial. It's kind of stupidly complicated and annoying, and every time you try to explain to people the problem, it's like, I can't reshape an array. They're like, well, I don't know how to. I mean, either they do one of two things. They'll be like, I have no idea how to fix that. That sounds complicated. Or two, that sounds trivial. Why is this so hard? And it is exactly that. That's most of the problems I have to deal with are those problems that are, why is that so hard type of questions. Let's see, what do we have here? I got a message. Oh, from someone in the Julia Slack. Oh, wait, you put me... Oh, okay, well, I appreciate that. Thanks so much. Who did that? Someone said I was in the Julia Slack. Freeman, I assume you're the one that posted that. Thanks a lot. Really appreciate it. But yeah, so I do regularly stream Julia development, but also I do regularly stream also C++ development, so I don't feel like... Anyway, I appreciate it. Thank you so much. Okay. Sorry, I was just looking through the chat. Tridy, thank you so much for following. Really appreciate it. Cool. So again, if you guys have any questions, comments, concerns, let me know. Problem is, it's not really an array. It's pretending to be an array. Right. So here we have 444. So that's a normal MPI state array. And then we'll take a look at the other array after that's done. Building CUDA native runtime library. Give it a second. Oh no! Come on! Don't give me that. What's QB still defined though, right? Okay, it's still defined. So if I do type of QB here, we're gonna have base reshaped array float 32. Oh, it's just so hard to read this. And if we do type of Q, we'll get MPI state array here. So the big thing to take away here is base.reshaped array has float 32 3, and then I want to say that everything inside of here is going to be everything inside of here. But I don't think that's right, because I think there's more lines up here. So I'm just going to try to figure out the difference between these guys real quick. Serious question, if you have a potential maximum value, let's say the power draw from a system, that value can fluctuate. My question is thus, would it be a bad idea to just use your max value as a constant? Maximum value for what? Let's say the power draw from a system. That value can fluctuate. So my question is this, would it be a bad idea just to use a maximum value as a constant? You can use your maximum value as a constant for most cases if you're trying to estimate your best or worst case scenarios, but usually, you can estimate like a percentage of that, or even better yet, a function of your effort versus time. And I think that's slightly better. Just take the maximum of maximum. Okay, so let's see. What do we have here? This is gonna be really hard to. Is there a way for me to just to figure out the difference between the types? Like base.reshaped array, float 32. So it's gonna be base.reshaped array, float 32, 3, MPI state array, float 32. Coup-array. Let's see. Coup arrays, and we should have clean meta MPI state arrays. And there should be a CM buffers. Let's see, nothing. Array, float 32. So this right here, from MPI state array here, that is exactly what's down here for type of Q. And then we have tuple, base of multiplicative inverse, signed multiplicative inverse, in64, base of and that's what I don't understand. Why is that showing up? 180 watts power supply is what can be supplied, but potentially not. So I'm struggling to think in a particular way. Right, so usually you'll have some sort of function of power over time, and you can like integrate this, and you can figure out, kind of an average or something like that. Taking, just to say it's always providing 100 watts, is a bit short-sighted, but can give you a, I think, but it can give you a good estimate for like the worst case scenario, what the maximum amount of energy over time you would be spending would be. Okay. So QB is going to be MPI state array float. And again, we have this base.reshaped array on top of it. So, we got base.reshaped array. Let me see what happens if we just do Q of 1. This should fail. That should also fail. That passes. That also passes. Okay. Let's try QB. That fails. Dang. That's exactly what I was expecting as well. So again, QB is a reshaped Q, and that's the one that fails. Okay, so good. Let's take a look at the code again. So I'm going to VI. I'm actually going to make this medium-sized. Oh, sorry. Medium-sized, and I'm just going to pop it over here really quick. Let me. I shouldn't have done it that way. Let me reshape this really quick. Over here. Move it up here. Perfect. Okay. Now let's open up this MPI state arrays.jl here. Can I ask you something about interpreting representative concentration pathways? Or is it bad at the moment? You can ask, but honestly, I don't know this part of the research. Really and truly, I was only hired because I know GPUs in Julia, and a bit about numerical methods. Well, a good bit about numerical methods. My understanding of climate simulations, specifically about, again, representative concentration pathways, is very slightly more than a normal person. I'm no way an expert in the area. So I can try to answer the question. And I welcome the question, but I can't guarantee I can answer it correctly, is what I'm going to say. Okay. So let's see, where is this? What happens if I just do @edit? What happens if I just do Q of 1? What is this going to pull from? This pulls from base.getIndex, as I probably should have expected. Okay. And if I do 1, 2, 1, it goes to base.getIndex. Again, fine. Okay, so here's that line in this file over here. Get index q.real data. Yeah, so all you're doing is if you're reading an MPI state array, you're outputting q.real data. So let's just go over here and let's see what that does, actually. So if you do q.real data, it outputs coup-array, float 32. Ah, that's interesting. It is a coup-arrays of float 32 3 coup-arrays. So what happens if I do qb.real data? That's not going to work. Yeah, this isn't going to work at all because reshaped array has no field real data. I guess that we could create functions that would go through and they would take any reshaped array and they would, any reshaped array of an MPI state array, and they would treat it as if it were an MPI state array. Maybe? because we can get the indices. Oh no, we can't get the indices of QB. That's the issue. Mama Dev, hey, how are you? I hope you're having a wonderful day. Okay, so yeah, really and truly, we just need to get this reshape function to output something different. And I think doing this C-call thing is just this way in which I wrote it is not going to work. Yeah, not bad, not bad. How's life? It's okay. I mean, again, everyone's in quarantine right now, so could be slightly better, but I can't complain. I still have a job. I'm relatively happy with it. I mean, I think it's okay. Okay. So this C-call thing isn't going to work. So what can we do? We can create a new MPI state array of the appropriate type and broadcast the data onto that. But that's really stupid, because that means that, what does the index function for QB look like? Yeah, good question. So let's do at edit QB of 1 to 1, let's say. And it will pull, function get index of an abstract array. So it's just pulling the get index of an abstract array, which is the just the default. Any array that doesn't have a standard type will just go to this. So that's what happens. You also have an unsafe get index, but I don't know if that's what we're looking for here. And in particular, I suppose at propagate inbounds meta error if canonical get index index style. So I guess it's grabbing this line here, error if canonical get index. That's probably what it's failing on. Okay. Yeah, and we did try just taking this C call and providing an abstract array, like another array type, and that didn't work. It has to be of type array, which isn't great. Man, I'm running out of options here. Let's see. So if we do MPI state array dot, if we do MPI state array, okay. So again, we can create a second MPI state array, and we can reshape that, or we can set that shape to be whatever we want it to be. But that's so stupid, because really all we want to do when we reshape something is we just want to access the elements differently. And honestly, I genuinely feel that the best way to move forward just to move forward here is to redo the entirety of MPI state arrays so that it has. Let me mess around with linear and Cartesian indexing really quick. Let's just see what we can do. I'm just gonna open up a second Julia shell here. I know it's weird to have two Julia shell opens, but I don't care. We're just gonna generate another one here. We're gonna say A is gonna equal to 1s of 10, 10, 10. Okay? If I do A of 100, this will give me so even though I started A as we'll do 10, 10, 10. Well, 9. That'll give me an element. But if I do A of 100, it'll also give me an element, right? So if I go over here and I do Q of 100, this should fail because scalar get index is not allowed. But if we do 100 to 100, sorry, we don't have 100 elements. So we do 2, 2. That should give an actual element, right? When looking at represented concentration pathways, projection based on RCPs, at the table AR5 global warming increase. Yeah, let me take a look at that. Right. So you're saying wait, which one? AR5 global warming. Yep, this one right here. In column 4, 2046 to 2065. Yep. I think all the confidence intervals of the different RCPs overlap in significant ways. So here are scenarios where we can't say whether we did nothing and continued growing or had an active carbon capture based temperature change. Do I understand that right? Let me reread that so just to make sure I can understand the question. I think all the confidence intervals of the different RCPs overlap in significant ways. So here are scenarios where we can't say whether we did nothing and continued growing or had active carbon capture based on the temperature change. Do you want? Yeah, actually, I think you are right in that. So here's 0.4 to 1.6, 0.9 to 2.0. Again, there's some range there. 0.8 to 1.8, like it's literally, I mean, they're all in the same range, 1.4 to 2.6. So, I mean, that's the issue, right? All these pathways are very muddled. So I believe your understanding is correct there. You know, like even if we do active carbon capture, we might still end up looking like we're on a different pathway. Even if we do everything we can to remove the carbon from the atmosphere, it's still not exactly clear which pathway we're on, even with that considered. From what I understand. Sir Bacher, thank you so much for following. Really appreciate it. Or Sir Baker, really appreciate it. Okay. AR5 global mean sea level meter increase. Yeah. Okay. I don't know. I don't know if that actually helped, but like maybe it did. I think you're right. That's all I have to say. Right. So basically, what we learned here is that we can index anything that's set as a Cartesian set of indices. We can actually index as if they were linear, right? So I guess my question is, let me try editing these guys. So we're going to edit a of 100, and this should give me a get index function, right? Eval get index array of I1 int is array reference expression balance check. That's not what I'm looking for either. Let's try this. Does that bring me to a different line? If I edit this, it might be the same line. It is actually the line under it. So we do. That sucks. I find it hard to convince people which die before 2065 that climate change matter if they might not see a difference in their lifetime. Yeah, right. I mean, I'm actually very heartened. I guess not disheartened. Like I'm very encouraged by the fact that, you know, during this crisis, the pandemic that we're having right now, people were able to kind of rally together and fight a foe that isn't exactly obvious, you know, like it's not, you know, everyone's staying indoors not because, you know, they're saving themselves, but because they don't know if they're sick or not, and it's better to protect others by staying inside type of thing, you know, like everyone's staying in to save society, not themselves type of thing. And that's really cool. And so I think this idea that you should do something for the greater good is still very much instilled into a lot of people. I don't know if this is generational or not, but I will say that most of the world, I think, does understand the idea that, you know, you should maybe sacrifice your own freedoms a bit, such that, you know, you don't hurt the overall, like you don't hurt other people type of thing. And I think if we can just somehow get people to believe climate change is just as threatening as, you know, maybe not just as threatening, but threatening as COVID is, or something like that. If we can just find a way to sell this in the right way, I think we could tap in that power again. That's kind of where I'm at. I don't have any good solutions except to just talk about it and hopefully do as much communication as I can on the subject and see where we go. But yeah, I don't know. Like a lot of people, you know, they look at the U.S. now and they're like, wow, the U.S. is so much better than it used to be in terms of pollution and stuff like that. And they're right. I mean, it's gotten way better. It's just here we are, young folks, and we're like, you have to get way, way better. And they're like, well, come on, we're doing our best. You know, I feel like we've already made a lot of progress on that front, and we have, but we need to make more progress. You know, what's your thoughts about putting used plastic in a big hole and throwing the sand over it? I don't know. It removes carbon from the carbon cycles. I don't know. I really don't. So kudos for making models with better confidence intervals. Right. I mean, that's kind of the whole thing for this one. I think the difference is that people can easily grasp the concept of diseases. Long-term climate change is harder to understand. Yeah. I mean, it's just so hard because you see the same graphs, you know, you see the same exponential growth, you know, in the climate that you see in COVID. And somehow, like, people are more willing to protect society from a pandemic. And I realize I'm speaking from an area of privilege, right? But I don't know. To me, they seem like the same problem, you know? I think the difference is that people can easily grasp the concept of disease. Let's see. Plastic is not unlike the trees. Is not unlike when trees started making lignin. Yeah, I don't know anything about that, unfortunately. Rugoru, thank you so much for following. Really appreciate it. Okay, so let's see. Expect there is one kind of lignin, but thousands of kinds of plastic. Except there. The Earth plus plastic. Yeah, I don't know anything about this. I should know more, but I don't, unfortunately. Sorry about that. Okay. So let's see. Eval get index A of array. I1 int. Yeah, I don't think this is where we need to go. I mean, obviously the issue is that we're trying to get an index from an array type that's too complicated. And I don't know. I think I'm gonna have to call in the big guns. Unfortunately, I'm at a stopping point here where I have absolutely no idea what to do. And after literally 4 hours of just struggling against this, I'm gonna have to either ask my friend who basically helped invent coup arrays, or my other friend who invented MPI state arrays, and it might have to be a combination of the two. Um, I always get slightly depressed when I have to do this because I should be able to do this on my own, but I don't know. I mean, I'm just not able to. I don't understand what I'm even supposed to do. So I'm gonna keep plugging away at it for the next 20 minutes, and if we can't find a solution, then I'll tag in someone else. Just a dumb question. Why don't you just allow scalar indexing? So scalar indexing in this fashion, there's a couple of reasons we can't. So the reason we can't allow scalar indexing um, is first of all because that's going to be a larger change in the Julia ecosystem. We'd have to modify coup arrays, which is kind of inbuilt in a bunch of other things. So it's just hard to modify that without modifying a whole bunch of different packages. The other issue is usually when you do scalar indexing, this inherently means that you're taking your data from the GPU to the CPU, and that's something you don't want to do because the transfer between the GPU to the CPU is just a slow process. And you want to make sure that all the computation you're doing on a coup array is being done on a GPU, just because that's when it's fast. It's not a dumb question, but I appreciate it. When trees first appeared, the bacteria couldn't break down the lignin. The result is that all the carbon got removed from the cycles and transformed into coal over millions of years. Ah, interesting. Love that comment, though. It's all Microsoft's fault. Wait, what comment are we talking about? Posting and gripe. Growth does require asking some help sometimes. I agree. It's just that a lot of times I don't want to be that guy who's always asking for help. I know that it is an option and makes GPU computation slow, but it's just an option. You see, right? It is an option, but also it's not necessarily an option in our case because the MPI state arrays are huge arrays in general. So if you have to transfer it to the CPU to do computation, this is just going to take hours to do that transfer. Maybe not hours, but it's going to take a long time to do that transfer, and you just don't have the time to spend on doing that. There's a comment on indexing function. This function is overly complicated, but will allow Win64 to work. Oh. Oh, I bet you it was, wasn't it? 64. Win? This is more complicated than it needs to be in order to get Win64 through Bootstrap. Oh boy. Gotta love Windows. Oh man. Every single time I'm trying to write code, people always ask about cross-platform compatibility, and I'm like, no. I don't want to have to support Windows. I'm fine supporting Mac, I'm fine supporting Linux, but supporting Windows is so hard. And it always boggles my mind when game developers are like, when game developers don't want to support Linux or Mac because they're like, oh, it's so hard to do. But I'm like, are you kidding me? You're already supporting Windows. And I get it. I get the reason why is because there's such a small market share in Linux. I get that. There's such a small market share even in Mac for gaming. I get it. It's so hard to maintain Windows code, I know it's an option. Let's see. There's a comment. What's wrong with Windows? I just have issues. Every single time I try to code something up for Windows, it's just a different ecosystem that I'm not familiar with. And in particular, when you're used to doing high performance computing, all of the supercomputers are running Linux or some sort of Unix variant at the very least. So you're very used to the Linux ecosystem and how it works and everything about that. So when you have to move to Windows, everything is now foreign again. And it's just hard. I guess porting between the two is hard. Yeah, I think that's actually the case, because again, I'm ranting from the opinion of someone who has basically only been developing Linux code. And in fact, all my Linux code, I mean, we do very basic things. It's simulation code. So you don't really need OpenGL or anything like that, which is incredibly complicated. I understand. But okay. So I guess what I'm going to do is I am going to... Let me just run a git diff really quick. Git status, actually. So we've modified manifest, arrays, MPI state arrays, and reshape.jl. And let me see what the git diff is here. Git diff source arrays, MPI state arrays.jl. Function base.reshape. What did I add? Oh, I just changed it slightly so it read an array type. Let me just I'll just change this back. So vi source arrays, MPI state arrays.jl. And let's go down to reshape. And let's go here. ft dt there. And let's just remove this call down here with the array type. And let's remove this comment there and that comment there. Okay. Going to vi test arrays. Then we'll do what am I looking for here? Reshape.jl. And I believe what I need to do is add the array type here. I'm just going to run that really quick just to make sure it does what we expect it to do. And I will keep plugging along, but I'm just not expecting to get anywhere in the next few minutes. Which sucks, but it is what it is. So I didn't want to change everything back to the previous, to where it was at the start of stream. And the reason I didn't want to do that was because we made some changes that weren't weren't committed, is essentially the issue. So that was why it was slightly more. Oh, no, there's no array type. Yep. Okay, this should work. So this will give us our dumb way of doing it. And then we'll just have to... I'm going to have to talk to someone about this. So I guess I'll just contact them and ask. CS_Peter1, thanks so much for following. Really appreciate it. Okay, so this will give us back our reshaped normal array. Not MPI state array, not coup array, just a reshaped normal array. Which is dumb. Super dumb. But it is what it is. Hey, Trash Talk, how are you? Thanks for coming in. Right. And then I guess in about 10 minutes or so, we'll go ahead and move on to the next bit of stream, which will be working on fractals and iterated function systems and stuff like that. There's a lot of little things we have to visualize there. What do you mean? No method matching reshape? Oh, I know exactly what you mean. Sorry about that. This should work. Yep, give it a second. Good feeling unproductive. Well, I just spent 2 hours and didn't get anything done either, so we learned a lot. But at some point, how is this failing? Okay, so let's just do Control D. Julia, let's try recompiling it one more time. And in the meantime, let me do git diff of test arrays reshape.jl. Should be fine. And we'll git diff, git dis, slightly different, of source arrays, MPI state arrays.jl. Looks like the only difference is this function call, which should be fine. Everything should be fine. Yeah, okay, still works. Cool. I'm just going to commit this. It's a small change. It's not a big change. It's just a small change to what we had before. So let's go do git status, git add source, I guess star, git add test star, git status, git commit, dash m, slight change to reshape function still returns a normal array. Okay. So this isn't great, but it's something. So git push, upstream, JRS, what am I looking for here? JRS, what is it? MPI reshape. Okay, I think I'm just gonna put a pin in this discussion for now. And I'm gonna go ahead and move on to the algorithm archive work. Man, that's disappointing. I was so hoping that we could just like run in here and get everything working, but you know, sometimes you just can't. And at this point, I've kind of tried attacking it for too long, and I feel like we're not getting anything. Are you doing Fractals in Julia too? Unfortunately not. The Fractals, well, okay, we are doing Fractals in Julia, but right now the visualization is in C++. So it's not quite in Julia. We could probably update the visualization engine so it is in Julia, but I haven't done that yet. I just haven't had the time. So it's unfortunately in C++. Sorry, Freeman. I do really appreciate the post in the Slack though. It's just that again, we're moving on to C++. So I do Julia for work, and I'll be live probably on Friday, doing more Julia development for a few hours. But yeah, I'm moving on to C++. Sorry about that. Cool. Actually, maybe I should mention that on Slack. So I'll just create a note. Just put it in streaming. Yeah, okay, yeah, I can. Okay. So let's see. Let me go ahead and change the stream title, and we'll go from there. When you go online and code Julia. Right, I mean, I do it regularly. Most of the code I write is in Julia. It's just the visualization is in C++. Okay, I'm gonna change the stream title, and we can move on to the next bit. Right, so let's go ahead and do that, and yeah, give me 2 seconds to do that. Okay. Okay, so the stream title should be changed. Right, to Fractals and Chaos Games, which is what we're working on next. When you go online, which Windows manager is best for streaming? I mean, it's completely up to you. It doesn't really matter the Windows manager so much. I'm using OpenBox. I genuinely like OpenBox. It's a wonderful Windows manager, but if you want to use something else, feel free to. I mean, like, it's your call. I mean, everyone's setup looks basically the same. They have some code. Oh, wow, okay. I forgot I had another terminal up. They have some terminal specifically for coding, and then they have some terminal for running. It all kind of looks the same. I mean, not everyone has 2 terminals up, but that's what I do. They usually have their writing here and then running here or something. Cool. Okay, let me go ahead and close this terminal there. Right. Thoughts on Juno? I don't use IDEs, so Juno isn't something that I'm too familiar with. But I am. I've seen people using it, and I think it's good. I mean, if you want to use it, use it. I know a lot of people use Atom instead. Cool. So what are we working on? Let's go ahead and CD here, and Control D, and clear, and we'll clear over here as well. Get ourselves a new slate. Maybe run the SL command. I don't know. Let's go ahead and do, it's the wrong SL command. This one's the one that I wanted. Okay. So now if we do CD into projects, Simuleos, and Fractals, and we do the same thing over here. CD, clear again, whatever. CD projects. Oh no. CD projects, Simuleos, and Fractals. We'll start working on the next bit. So let's do, let's talk about what we've done so far. I'll show you the last visualization we did with Fractals, and then we will start talking about where we're going from there. Again, if you guys have any comments, questions, concerns, ideas, anything like that, feel free to let me know. I know there's a lot of, like, we're doing a lot of stuff on this stream, and it's all very complicated. So, you know, if you have questions, it's my job, it's my goal to be able to answer those questions in as clean a way as possible, such that everyone understands. So let's go ahead and go. I think I have a video in here. Maybe not. Let me just run /Sierpinski. This should generate a video, I think. And in the meantime, I'll open up a terminal and hide it behind my face so you can't see it down here. And that'll be my running terminal, my play terminal. How are babies made? Unfortunately, Vexitose, I have not yet figured that part out. I tried simulating it at some point, but apparently epidemic algorithms were not the way to do it. Then I tried genetic algorithms because it was in the name. That also didn't work. It just doesn't. It doesn't really. I haven't quite figured it out yet, but I'll let you know when I do. So we're gonna CD into storage, videos. Oh, this is what I'm doing. I don't know what I'm doing. In fact, I don't even know what I'm rendering here. Let's just let the render finish. I'll show you the visualization, and we'll talk about what we need to do today. It's like a whole bunch of small scale things to do. Again, this isn't going to be so much like, we're not doing new visualizations today so much as we are cleaning up old visualizations, which could be interesting to a lot of people. I think it's interesting, but might also not be interesting. So we'll see. Whatever you guys, it's not whatever you want to do. We have like a goal of stuff that we need to get done. But yeah, I think it's Wednesday. I really, really want to get this video out on Sunday. I really do. Oh God, why is this a thing? Oh, but I'm clicking on it anyway. Okay, just in case, I'm gonna put a screen up, and I'm gonna open up that link. Okay. Yep. This is okay. I was just making sure there wasn't anything like bad on the link. I mean, I knew there wouldn't be, but like, just in case. Let's see. Due to Newton's third law. Okay, interesting. Right. Yeah, it's Wikipedia. I probably shouldn't have worried about it, but sometimes, I don't know. Sometimes I do. There was that one page we went to a while ago for the Easter algorithm that had weird stuff in it. So let's do MPV temp video.mp4, and let me also loop that. So this is the last animation we made just a second ago, and I'll describe what it is doing in just a second. Just numerical fractals, or are you also doing fractals based on symbolic replacement like Lindenmayer systems? So in particular, we're focusing on iterated function systems. These are function systems that allow for you to generate fractals or fractal-like systems by basically iterating through a set of functions. And I'll describe what that means in just a second. This was the very last animation that we made. Again, I'll play it from the start really quick so you guys can see it again. So here's the animation that we just made the other day. What we're doing here is we're taking points A, B, and C, and we're giving them 3 sets of functions, right? So one function will bring you halfway towards A, another function will bring you halfway towards B, and another function will bring you halfway towards C, right? And what we're doing is we're having A, B, and C all generate 3 children. And then after they generate 3 children, one of their children will follow one of the functions, right? So A will have 3 children. One goes through function 1 and moves halfway towards A. It's already on A. Nothing really happens. Another child moves halfway towards B, and another child moves halfway towards C, right? And then B generates 3 children following a similar rule, and C generates another set of children all following a similar rule, and essentially all of those children then spawn 3 more children that also follow a similar set of rules. So we have children generating children generating children, and then it generates basically this visualization that you see here. I'm a very big fan of this visualization. It isn't intuitive, but I like it. And so now my goal for today is to turn this animation into something intuitive. That's what I'm trying to do. I think I know how to get there, but we got to do it. So in particular, let me go ahead and pause this video, go back to good old Zernal PP, and let's talk about what an iterated function system is and how we're using it. Math. All the cool things are math. So, like, unfortunately, you're right. Iterated function. That's not how you spell function. System. Okay, so here's the thing. You have a function system, and you're iterating through it. For Pete's sake. And you're iterating through it. That's what this means. Zernal, it's just it's Zernal++. It's just the writing program that I use. So let's say we have three particular points in space. One here, and one here. So we have A, we have B, and we have C. Right? In the wild? I can't believe. Wait, what do you mean in the wild? Wait, am I wild now? F1 is going to be equal to some sort of point in space plus A over 2. F2 is going to be some sort of point in space plus B over 2. And F3 is going to be, again, some sort of point in space plus C over 2. Yeah, I've been using Zernal basically for everything. So, I mean, not for everything, but it's just my go-to drawing thing. I don't know if I said thanks for following, Freeman, but I appreciate it. Thanks so much for following. I think what you contributed to it, dude, amazing. or raised a bug. Yeah, it's something. Okay, so this animation that you just saw basically has A generating 3 kids. One moves halfway towards A, so it sticks here. Another moves halfway towards B, and another moves halfway towards C. B then generates 3 kids. One stays at B, another moves towards A, and another moves towards C. And then C generates 3 children. One stays at C, another moves up here, and another moves over here, right? Those 3 children generate 3 more children. So, for example, this guy will generate a kid that goes here, here, and here. The orange guy will generate a kid that goes here, here, and here. And the pink guy will generate a kid that goes here, here, and here. And eventually, after generating enough children, we generate something that looks like a Sierpinski triangle. So that's the animation we just made. And again, today is going to be a lot of working with the animation we have to make it more, first of all, visually understandable, and second of all, a bit cleaner. Like just coding wise, there's a lot of like magic numbers in this code that I just want to get rid of. So I'm going to be working on that a lot. Oniru and Nick, thank you so much for following. Really appreciate it. That's a very backwards way of generating such a triangle. Right, because the regular way for people to generate the triangle is through something known as a chaos game. Yep, that's normally how people do it. In which case you just take some random point. So, you know, if here's A, B, and C, you just take some random point in space. I guess I'll put it here in green. And then basically what you do is you have this guy randomly choose between function 1, I guess I'll draw it this way. It randomly chooses between function 1, function 2, and function 3, right? And then every single time step, it just randomly chooses between a new point or a new function to move along again and again and again. And that's kind of what it does. And then eventually you generate a visualization that instead of looking like this, will instead look something like this. Let me see if I can find it really quick. Projects, Simuleos, Fractals, and it should be video.mp4. It'll look something like this. The problem with this one is it's less visually intuitive as to what's happening, but you do definitely generate your triangle in this way. So, right. Is the goal to explain iterated function systems? Right, that is the goal. That's a Mason? I don't know what a Mason is. Is the goal to explain... I just did it with SVG. Oh, right. Yeah, you can do it in a number of different ways, right? The goal of this is to explain specifically iterated function systems. So for here, let me just show you where we're going towards. So I'm going to open up another terminal. We're going to cd in projects, algorithm archive, ls here, and git branch. Git checkout. What did I call it? IFS probably. Okay, git book serve. So for those of you who may be here for the first time, you've never been to this channel before, my side project is working on well, 2 things. One is a YouTube channel called LeosOS with 7,000 subscribers, something like that. So it's all about algorithms and explaining them and stuff like that. And the other project that I work on is the algorithm archive, the Arcane Algorithm Archive. It's your one-stop shop to understanding algorithms is the idea. It's supposed to explain in adequate detail what, for example, Monte Carlo is. When I say adequate, I don't mean a super large amount. I mean, like, if you've never heard of Monte Carlo before, this is supposed to give you an explanation for what it is. And then what you can do is you can switch between all the different languages, right? So, for example, if you want to see Monte Carlo written in Julia, here it is in Julia. And I usually implement all of the Julia implementations. And if you want to see it in emoji code, here it is there. Euclidean algorithm, for example, even has white space down here. So here's white space for the Euclidean algorithm. So what I'm working on right now is a chapter on iterated function systems. All the text is basically ready to go, and I'm working on the visualizations for that. And also my YouTube channel, in case you guys are wondering, is here. So I'll just give you guys a link there to the YouTube channel there. And then I will also give you a link to the algorithm archive here. Okay, cool. So that's just in case you guys hadn't been here before and you didn't know the project because you just came from the Klima stream. I understand that was a bit confusing. I probably should have spent a bit more time explaining what it is that I was doing. Cool. Okay, so that's kind of the iterated function system. Essentially, as long as you iterate through a function system, you will be able to generate some sort of what's called an attractor. In this case, the attractor is a Sierpinski triangle, but it could be a number of other things. Yes, please feel free to ask the question. Thanks, Trash Talk. Let me get some water. Actually, maybe we pause here for questions in case anyone has any. I do a bad job of pausing for questions. I don't know if it's something we should do. Um, because I've had a large number of, I have a large number of emotes. I think I might do a raised hand emote. But maybe people could just use "Hey guys" for that. I'm not really sure. What's the real world application of this? That's a very good question. So I actually mentioned this in the chapter, I believe. Fractals show up all the time, right? They show up a lot. And it's kind of weird the places that they show up, right? So if you're asking where the utility of fractals are, fractals can be used to describe basically any rough system. And it's really cool when you start thinking about the world in a fractal-like way, because a fractal is somewhat defined as anything that has a non-integer Hausdorff dimension. I see you, Trash Talk. Thanks so much for coming in. Have a wonderful evening, and hopefully I'll see you next time. I will be trying to do earlier streams, so I think I'll start streaming at 4 o'clock p.m. When I can. I can't do it tomorrow, and I can't do it on Mondays, but Tuesdays, Wednesdays, and Thursdays, I'll start streaming at 4 o'clock p.m., and I'll do a Klima stream for 2 hours, and then I'll do the Algorithm Archive stream for 2 hours after that. That's going to be my goal from now on. I don't know if that's actually going to happen, but that's my goal. What time zone? Eastern time. Sorry about that. Right, so as far as fractals, you can describe any rough surface as a fractal, which has obvious applications in geography, turbulence modeling, all this kind of stuff. For iterated function systems in particular, there is some utility in understanding like what is the attractor for a particular system and stuff like that. But you're right that it is kind of a bit more mathematical, and you have to think about the applications a bit more. It's not as, you could say, globally useful as a climate simulation. It's harder to explain why this would be useful. In the Algorithm Archive, I mentioned a few different ways that people have used this type of code to do like fingerprint scanning and stuff like that. But it's always it's a weird application. You find it in a bunch of weird places. Sorry if that was a bit too long of a discussion about that, but hopefully some people thought it was useful. Tommy Two Toes, hey, how are you? Feel like it's been a while since I've seen you on stream, but I know I saw you just the other day. I don't know why. It's just because you were here from a long time ago, like almost a year or two back. Every time I see you in stream, it's like, oh, hey, it's been a long time, even if I saw you yesterday, Okay, so what I'm going to do is I'm going to have this visualization up, maybe in the upper corner here, while we just kind of work with the code a bit. I'm actually a very big fan of this animation, but there's a few things I really need to do to clean it up. The first thing is, if you look at it, you'll notice that there's a whole bunch of, here, let me move forward a bit. At about, wait, I'm gonna let it finish. At, almost there, give it a second. It's still good, give it a second. At this point, the triangle is basically completely formed. However, you still have all of these sets of 3 moving around. And you might be asking, well, where are those sets of 3 coming from? That's a good question. It's something we're going to fix today. So let's do journal, new page before. So like I said, the way that we're generating this animation is we're starting at point A, and then we're having it generate 3 children. And then those 3 children generate 3 children, and 3 children, and 3 children. Those 3 children, more and more kids are generating lots of children. Just a whole bunch of them. A big squiggly line of children after that. The point is, if all the points at A are following function 1, right? But function 1 is going to be the point plus A over 2. Well, okay, this means that all of this guy's children are going to be at the same location here. So that means this entire branch, this entire set of kids along this group are unnecessary, because it means that they will basically be following paths that the other groups are already following, right? So we can get rid of that entire branch, and that's something we need to do. I just need to figure out how to do it. So the first thing I'm going to do today is just clean up the code a bit, get rid of all the magic numbers that we have in there, and the second thing is I'm going to try to clean this up. How does it know when to stop? It knows when to stop in 2 cases, in 2 different ways. One, I tell it a maximum level to go to, so here level 4 or something like that. But also I give it a number of frames to draw. So I say only draw the first 3,000 frames or something like that. So those are the ways that it stops. Either it hits 3,000 frames, or it goes past the maximum depth or to the maximum depth, depending on how you define end or stop. Popping in now and then to make sure you're doing good. Well, hey, I'm happy to hear that. I hope you're doing well as well. I've been with you since the beginning. Yeah, probably. Actually, you might have been one of the first people to follow. I could go back to that list and see what it is. Oh, you might have seen one of my 2 Guild Wars streams I did that I just talked about earlier. Oh, it's been ages. I've been thinking about doing another one. If we can get this video out on time, I might do a Guild Wars stream on Sunday. I might. Probably not. Maybe. It's something that's in my head. Right, so let's go ahead and get this video just playing in the background. While we just kind of edit the code, I just kind of want it up here in the upper right-hand corner, just so we have it there. And we have a goal that we're going to work towards. So let's just move that down here, I believe. It's fine. There, perfect. He reminded me of Vitalik. Who is Vitalik? I'll take it as a compliment. Anytime people say that I remind them of someone else, usually I take it as a compliment. Because if I remind them of someone else, that other person is probably famous. So, you know, they're famous for a reason, and I take that as a compliment. Ethereum guy? I don't know who that is either. Maybe I can just look this up really quick. Let's see. Is a... Oh, interesting. Cool. Let's see. Ethereum, Bitcoin. Oh, Bitcoin. All right. Open source, public blockchain, distributed. Right. I know this. Just had to make sure it was the same thing. Cool. Okay. So what are we going to do? We are going to go ahead and open up the code, mess around with it a bit. It's going to be a bit of a chill, relaxed stream while we just kind of fix some numbers and just talk, chat, all this kind of stuff. So if you guys have any comments, questions, concerns, ideas, you want to talk about life, liberty, the pursuit of open source software, whatever it is, feel free to let me know, and I'll do whatever I can to answer it as soon as I see it in chat. I miss your YouTube videos, I'm assuming. I'm assuming it's YouTube videos. But I'm gonna wait because maybe it's something else. But I'm like 90% sure it's YouTube videos. Let's go to VI. Oh, I just missed you. Oh, thanks, man. Oh wait, do I know you? Are you? I think I know. Okay, then I do know you, and I know exactly where you're at. Hey, how are you? It's been a while. I don't want to talk on Twitch chat though, so maybe we should catch up on Slack or something like that. Open source is great. Let's see. What do you think of Bitcoin? Is it useless? I really wanted to support Bitcoin a long time ago, but I didn't because I was sitting there. I was like, Bitcoin's amazing. But I didn't have $100 to spare, and I was going to put $100 in Bitcoin right when it came out, but it didn't. I just didn't, and now I feel really bad about it. I think I just caught a major case of plagiarism going research for my class. Oh, that sucks. You caught a major case of plagiarism. Yeah, I don't know how to help with that, but I think I just caught a major case of plagiarism doing research for my class. Yeah, I don't know how to help with that, man. Ronin777, thanks so much for following. Really appreciate it. Hey, Jump Out, how are you? Let's go into VI. What am I looking for? Sierrapinsky.cpp. Also, it is dreadfully hot in this room. Might be because I'm in Alabama, but yeah. How's the Sierrapinsky D-resolution going? Okay. Imagine being rich and buying NVIDIA GPU. I'm not... It's a 970. Like, you can buy a 970 for pennies. No, I mean, not pennies, but... I mean, if I went to Amazon right now, and I let me see, Amazon.com. Well, what if I just Google buy GTX 970? Let's do that. Let's see. On Best Buy, you can buy a GTX 970, 4 gigabytes, the exact same thing that I have, no longer available in new condition. Okay, fine, fair enough. It's not particularly expensive, is what I'm saying. Like I found 2 papers that look the same, but with different authors and research labs. That's either plagiarism or they worked together. But even so, it's still plagiarism, even if you write your own paper. Like, you take a paper and you rewrite that exact same paper and publish it somewhere else, that's still plagiarism because you're self-plagiarizing, you know? So no matter what, it is a case of plagiarism, unless there's some licensing reason why it was allowed. Buying an NVIDIA Tegra SoC board. It runs Ubuntu. Oh, huh, interesting. Cool. Okay. So again, the first thing I'm going to do is get rid of all these stupid magic numbers so I can make a variable resolution simulation, which I don't have right now. Right now it's kind of set. The resolution I'm running at is 1920 by 1080. And if I change those numbers, the triangle does not change with it. So let's go ahead and make this scalable. That's the first bit. I'm going to start with the Sierpinski-Hutchinson visualization here. And I guess we'll just kind of I guess we'll just kind of mess around. So why did I choose 400 and 800? What was I doing? With this visualization, why did I do it this way? Okay. So the first magic number I see as I go along here is this 400 here. This means 400 pixels. And then I do plus 800 times triangle points dot x and triangle points dot y. So the triangle points are going to be at 0, 0.5, and 1. Right? So that means our triangle is going to be of size 100. So what is 800? In terms of, we'll go up here and we'll define two values, which will be triangle size. And this is going to be equal to an int. And this will be, let's see, 800. So what if we just do world dot size dot, what's 1920 by 1080, right? 1080 is going to be on the y-axis, so world dot size dot y times 0.8. Okay. And let's see, the other one looks like it's an offset of some kind. So maybe we do triangle. Why do I have my plus 400? We'll do triangle offset probably. And we'll do this times 0.4. Okay? And so now we just read these guys in. So triangle offset. And we'll put another triangle offset here. And we'll do triangle size here. And we'll put another one down here. And just because I feel like it, I'm going to move some of this to the next line there or something. I don't know. We'll just pretend this. We'll pretend this looks okay. Cool. So 2 magic numbers gone. A lot more magic numbers to do. Let's see. $129 to $899 for a complete board. Interesting. Hi, I'm back. I just went through a ton of thinking about how to format a JSON file to represent a list of D&D races, and then a ton more thinking about how to process that correctly in my code. And I'm reminded of why I hate using JSON for stuff. I've never used it for stuff. I don't know. 0, 0 in the middle of the screen. I think what I'm doing is I am trying to offset it so 0, 0 is in the middle of the screen. Let's see. Feel your pain? I made a Pathfinder character sheet in C#. Oh boy, C#. JSPP loved C#. But honestly, I couldn't get into it. I just couldn't. I kept trying, and it's hard for me to see perfectly object-oriented code, you know? It's not perfectly, but object-oriented code, purely object-oriented code, just is hard for me to understand. It is what it is. Okay, so I think those are the only magic numbers we have. So let's see if we have any more 400 in here, because we should. Yep, here. So we're going to change all the 400s. Let's just change all of these guys to be triangle.size. So we'll do, what did I call it? Triangle offset. Let me just search and replace. It's easier if I do it correctly. Search for 400 and replace by triangle offset. And then CG. Yep. Nice. Okay. So now we're going to search for all the 800s, and we're going to replace that with triangle.size. So we'll do S, and we'll do 800 and triangle underscore size. Okay, CG again. Yep. Okay. Then I think what I need to do is define these two guys for, oh, where are they? Oh, I'm on Sierpinski Chaos, not Sierpinski Hutchinson. And let me just go ahead and, okay, so let me get this to compile, then I'll go through and I'll fix it. So we need to grab these two lines, so I'm just going to do yank theory yank, and I'm going to move it down here to where we have Sierpinski Chaos defined, which should be here. I'm going to paste it there. Right, this should compile if I run G++. Does not, because I don't have a G++ event. So let's go up here and let's grab that compilation string, which is annoying as crap, and I know I should have a makefile. Don't tell me how to live my life, okay? I know a makefile is necessary. I know I should have had one. I don't, okay? I'm sorry. Okay, so we're going to change this to home James. Oh, gosh. Home James projects. Okay, keep going. I think there's 2 more up here. Home James projects. Oh, that's not how you spell home. And we need 1 more over here. So this should compile. Home James projects. Cool. That doesn't compile, but that's fine. Let me catch up on chat. I hope everyone's Quarantine is going okay. I mean, I realize it sucks for a lot of people, and I realize, there are a lot of issues with it, but I suspect if you're here, you're probably, at home, alone, or maybe with your family or something like that, but still at home. Yeah, and I hope you guys are doing okay. I mean, you still take time for physical activity, and you do what you can to keep yourself, active and sane. When I first joined your stream, I was taking education to become an MSCED. Stuff happened. I'm now a Linux consultant. Oh, dude, C# ain't that much used anymore. First of all, I think it's really cool that you're a Linux consultant. Like, honestly, I love Linux. It's so cool. And I think it's really cool that you're doing that. Let's see. Second of all, yeah, I mean, things happen. And I know C# isn't used that much, but, I hope that, you enjoy your career nonetheless. So code to handle tabletop RPGs is usually rather frustrating, it seems. They have that thing you see in trading card games where the rules work like this, except if something else specifies otherwise. So you need to encode all possible ways to specify otherwise, and you need your code and rules to be extremely generic. Right. I can see that happening. It's used in web backend. C# ain't used that much anymore. That was a personal statement. Sorry. Let's see. As in, I don't use it much anymore. I should have been more clear. Right. I've never used it. But yeah, it's used a lot. For example, with I don't know, like Unity and stuff like that. Player Anonymous, thank you so much for following. Really appreciate it. Ornog Live 4, Fractals and Chaos. That's exactly what we're doing. Sia Freeman, thanks so much for coming in. Have a wonderful evening, your time, and or whatever time it happens to be your time. And I will hopefully see you around next time. I will try. Maybe I'll post in the stream chat for Slack next time that I go live with Julia's stuff, which should be on Friday, I think. Everything Windows integrated. That's where it shines. Probably. I just don't use Windows, so, Is this the one who calculated the day of Easter? It is. Hello. Welcome back to another stream. Hopefully, we won't take 2 weeks to get this simulation done, where it took, I think we did 16 streams to calculate the date of Easter. Hello, I think that it's really hard to find channels like this, like do art with code and have this kind of Linuxness. I really like this type of channels and really help me to control my anxiety and stay motivated. So thank you so much for doing this type of content. You might know you might know it, but you at least help me. Thank you so much. Hey, Sensamoon, I really appreciate that. Or Senko Moon, I really appreciate that. That's why I'm doing these types of streams, because, one of the reasons, right? Like, I feel like people don't have a place just to express themselves in, I would say, technically literate ways. Does that make sense? And I'm really happy that this has helped you in some way, The creator Game of Life died in Corona. I made a Game of Life thing. Yeah, share it. I want to see it. If you can. I would love to see it. I was thinking about doing something similar, and I just didn't know. I was debating between doing like a Game of Life thing or a Doomsday algorithm thing, and I was like, well, Game of Life would be better, but Doomsday algorithm is easier. So I don't know. I decided I wouldn't do it. Because it felt kind of, it felt like I was doing something, like if I did Game of Life, I'd have to write an entire chapter on cellular automatons. And it's not something that I've done before, right? So it's a lot of stuff I need to learn. Senko Moon, thanks so much for following. Really appreciate it. Game of Life is a good training exercise. Good work. Doomsday algorithms is a lot like Twitter integrated systems. Yeah, it's actually just calculating like dates and stuff. So it really would have followed, like, it worked very well with the Easter algorithm, but I just decided not to do it. My algorithm is super advanced. I have Zimby cells. Dead cells have to rot or be eaten or to disappear, or part of food. Huh. Zombie. Yeah, zombie is different than Zimby. Let's go ahead and figure out why this is failing, and it's because I misspelled triangle. How do I spell it? I spelled it trying. So let's just add an L to all these guys. L. Is that it? I think that might be it. G++? No. Let's clear this a couple times. And let's try it again. G++. Oh gosh, I think I screwed all of them up. Let's just fix all of it at once. So we'll search and replace for any of the triangle. Okay, let's see what happens if we write and compile that. Does compile. So now what I'm going to do is I'm going to fix up the formatting a bit, just so it's a bit cleaner, and everything fits in 80 columns. I know that's not a necessity, but I just like everything fitting in 80 columns, and you can deal with it, Good. And let's do it again down here. It's just personal preference. I know a lot of people make fun of me for doing that, but I like my code to look a certain way, and again, it doesn't matter. Let's see. I think that was the only thing I had to fix. These guys as well. Okay. And then once these are fixed, I'll compile it one more time, and we'll run the animation, and just make sure it looks identical to what it looked like before. And if it looks the same, then we know we are good to go. I'm going to do both visualizations, just to be sure. But I think we're good to go. So let's go ahead and G++. And then we'll run /Sierpinski. And this will generate the same animation you're looking at in the upper right-hand corner. Let me just Control-C, so it's not going to be there for a bit. Let's see. Oh, yeah, let me take a look. It's on itch.io, too. Super cool, man. Let's see. Relevant XKCD. Of course, there's a relevant XKCD. There it is. I was about to ask why you didn't. Yeah, I just didn't. I should have, but I just decided against it. Why did that not pull up? Oh, that's because I Googled it wrong. Oh, I saw this one as well. Yeah, it's cool. Cellular automata? I actually don't even automata. I don't know how to pronounce it, honestly. It's on Windows, so I can't play it. But yeah, super cool, man. Like I'm a big fan. Good job. I just like everything fitting into 80 columns. Yeah, I'm sorry. It's just my thing. It's what I do. I missed a follow. Carlos Selajamaj. I really butchered that name. I apologize, but thank you so much for following. Really appreciate it. So let's keep going. So the visualization should be done now. Let's go ahead and play it, and hopefully. Oh no, it's not done. It's still rendering. We'll let it finish rendering, and then we'll take a look at it. Cool. And then after that's done, we will try to figure out the rest of. We'll try to figure out that other issue where we had way too many elements. Come on, there you go. Look at that visualization. Man, I like that visualization. It's so cool. I mean, yeah. Look, I understand there are cooler visualizations out there. I know that, but I like this one. I think it's cool. I tend to like things that I make though. So. Clean Star. Oh, Clean Star. Thank you so much for following. Really appreciate it. Cool. I'll let this play for the end just to make sure the same frames and everything are done, and then we'll take a look at the next visualization after that. Oh man. Okay, so I've been streaming for 2 hours and 30 minutes now, and I don't normally stream for that long, so I might have to stand up for a second and do a quick stretch or something, just because I'm not used to. I usually walk around a bit when I'm doing when I'm programming and stuff. So I'm not used to sitting in the same spot for so long. That seemed to work okay. Let's take a look at the other visualization for Sierpinski Chaos here and there. 20,000. What? I'm gonna make it 1,000 frames. What am I doing here with Sierpinski Chaos? Sierpinski Chaos reads in world, int n, and bin size. So what is the 1200? Let's modify this a bit so we have end frames actually being read in here as well. Just because I feel like it, and then we'll generate that, and I'll catch up on chat after that. So total frames is what I did there. So int total underscore frames, just keeping the same notation. So let's grab this, and we'll do move down here. Int total underscore frames. Okay. And then down here, we'll do total frames as well. Here it is. So we'll give it a cutoff of like 1,000 frames this time or something. Okay. And then we just have to modify the code. So it reads in, we could do 1,200 again. Why not? And that should work. So let's go ahead and run G++. /Sierpinski. And this will generate a different visualization, but it should be relatively similar. The code is a representation of its author. Tidy code from tidy authors and messy code from messy authors. I too try to make it look decent. It's very neat. Yeah, so the other thing too is I feel like because I don't use syntax highlighting, I have a different level of tidiness I need in the code in order for me to read it, you know? Like I tend to be very I tend to be very careful about how I not necessarily variable names, but how I write the code such that it's visually understandable. Let's see, Abbott3667 and Jamie, thank you so much for following, really appreciate it. Let's see, Are you Linux? My next project will be Linux for you. Oh, it doesn't have to be for me. But yeah, I use Linux. That's what I use. Um, if it will be your kind of project, math algorithms that you can't explain to mums. Oh, I mean, look, you don't have to make it for Linux just for me. Make it for Linux because other people are interested in it. If other people don't want to see your code on Linux, I mean, I would love to. I would show it off here on stream if you make it. I definitely would. But you don't have to make it for Linux just for me. You know. It'd be interesting in drawing. Wait, let me see. I missed a comment. Is A, B, C constant? And if not, how do you update it? Right now, A, B, and C are all constants. I could update it so that we have a struct that has all of the values that we need for this simulation inside of it. And maybe that's what I should do. And it has triangle points and all that kind of stuff inside of it as well. But yeah, I could update A, B, and C if I wanted to move them around. It's just for this particular case, I kind of like the fact that the triangle is equilateral or whatever. Yeah, so there's our other animation that we have. Nice. So I kind of like how A, B, and C are like here, here, and here, because it just makes the visualization a bit cleaner. Again, in essence, you could put them anywhere. I suppose when I write the Julia code for this, which I think I already have, I should write it such that you can pick A, B, and C to be whatever you want it to be. Let's see. The language is C++. Forgive me if I miss anything in chat. I'm doing my best to catch up on anything. If I did miss something, just say it again. I'd be interested in drawing the tangents if each of the three main vertices were offset by 90 degrees to each other in 3D. That would look fantastic. C++ confirmed. File CPP. It's C++. That's what I'm using. I'm using C++ for this visualization. In particular, we're using a library known as GathVL. Gathros was here a while ago. But yeah, this is the library that we're using. It's just a visualization library that we use. It looks a little bit stretched vertically. Oh, you're right. Maybe it isn't. Maybe it isn't an equilateral. Maybe I was an idiot. You're right. It's not equilateral. Because my triangle points are not set to be equilateral. So let's modify the triangle points. Okay, so our triangle points are 0, 0, 0 0.5, and 1, and 1, 0. So what I want to do is I want to make it so, let's just do some silly math. So we have, here's our x-axis. Here we have a point over there and a point up here. So we want this to be 1, and we want this to be 1, and we want this to be 1. Okay, let's just say that's what we want. That means I'm going to do negative 0.5, negative 0.5. Where did I put these guys? So it was 0.5. So it was 0, 0. Where did I put them before? So it was 0, 0, 0.5, and 1. X, Y. What? How does this work? So before I had it on 0, 0, 0.5, and 1. Oh, I see. And then 1, 0. That's what I had it on before. So I'm going to keep the 1, 0. And what I need to do is I need to figure out what this value here is for Y. Okay. Fine. Fair enough. It should be square root of 2. Because a squared plus b squared, square root of that is going to be square root of 2. So let's just plug that in there. Oh, 0.5 is correct. Why did I have to do that? What? I knew it was supposed to be square root of 2. Like, come on. How dumb am I? I'm sorry. I know there's a lot of people in chat who maybe didn't know that. It's just basic geometry, but... Is this... Let me think. So it goes from... So that's 1. These are 1. Has to be right. Right? Now let me catch up on chat here. Hey, OS Frog, how are your mercs? Let's see. Why don't you use an editor with color? I just don't like color. It is what it is. I just don't like it. A bit off topic. What's your Windows Manager? My Windows Manager is OpenBox. Let's see. It's described in a blurb down there to the left. It states, long ago there was a bit of a war between Church of Emacs and Cult of VI. In my mind, VI won. I don't use Vim. I use VI. No color, no tricks, just VI. Why? Well, it's because that's how I learned, and colors freak me out. Deal with it. That's what it is. Let's see. Sin 60 cosine. Can I get this editor for Windows? I'm sure it's just Vim. all you have to do is just run vim, and then here, let me show you this code. So I'm gonna open this up in huge. Oh, that's large. Let's make it. No, that's huge. Okay, let's move it over here. CD projects, simu, Laos, Fractal, and if I run vim, Sierpinski. I don't know why I opened up a new terminal for this. I just did. .cpp, and I do syntax on. Yeah, that's all you have to do is type syntax off. And also what you need to do is vi .vimrc. And what? I don't have a vimrc. Okay, I guess I don't have a vimrc. Sometimes you have to do other things as well. Okay, so what do you have here? Ornog, yes, you can. Zernal as Windows. Oh, you're totally right. I am wrong. You're totally right. I did that totally wrong. Captain O'Conrad, thanks so much for following. Really appreciate it. Let's, I'm an idiot. Obviously, right? It's not a squared plus b squared. That gives you the hypotenuse. It's going to be, c squared minus a squared, which is going to be, what? That's not right either. C squared is equal to a squared plus b squared. Right? So if I'm looking for b, it's going to be c squared minus a squared. What? I have Zernal now. Cool. Yeah, I like Zernal. It's nice. The painting is in Zernal. Just Google for it. Oh, I'm sorry. I missed something. I missed the painting editor. Sorry about that. Square root of c minus square root of c squared minus a squared. But c squared minus a squared is going to give you... Oh, because I'm an idiot. Gosh darn it. Why am I so dumb? A, in this case, is going to be 0.5. So it's going to be 1 squared plus 1 squared minus 0.5 squared. So minus 0.5 squared. So minus 1/4. Okay, so it's going to be 1 minus a fourth. So it'll be 3/4. So it's going to be the square root of 3/4. Okay. Has to be it. Right? I mean, come on. I can't be that dumb. I probably am. Let's run it. Let's just see what it looks like. Oh boy. Don't do physics, kids. Yeah, it'll ruin your math brain. You won't have one anymore. The square root of the tangent differential is 4a fast. I don't see how that's related to an FFT. I don't. But hey, you know, I'm just a measly physicist over here. I don't know what I'm doing at all with life. But yeah, if you guys have any, thanks so much for catching that, guys. I didn't even think about that. I just did it. I was like, square root of 2 has to be it, because you see square root of 2 so many times. I'm like, oh, duh. And I was an idiot. Physics, not even once. Gabriel GPC, thank you so much for following. Really appreciate it. Let me get some water. If you want a Sierpinski with enough convolution matrix, I don't see how convolution could help here, but yeah, feel free to talk more about it. Linear algebra is an integral part of modern math. Yeah, it definitely is. It's also an integral part of programming. Let's see. Do you have an alias that swaps out VI for Vim? Because they're very similar, but also a fair bit different. Also, line numbers. You don't like them? I just don't use them here. Because when you set number... So the reason I stick to the 80 column rule is because when you open up a terminal, it's always... you open up a terminal. Let me just... Here's a terminal that I just opened up. I'm going to make it huge. And I'm going to open up VI. Okay? What I'm going to do is I'm going to count. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, I'm just going to keep going. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 0, 1, 2, 3, 4. Every terminal you open up is 24 columns, or 24 rows large. Okay? And the $, it is the $, here. DG, sorry. It will be 80 columns. So I'm going to type in 80 I dash. That's what I'm going to type in. So let me type that in. So 80 I dash escape, exactly 80 columns long. So the reason I don't set number is because if you set number, it uses a few spaces here, right? Just a few spaces there, which means you're no longer following the 80 column rule because you're wasting a few spaces here for the numbers. That sounds really dumb. I know it's really dumb, but that's what I do. So I'm sorry about that. I can always set it if I want. As far as an alias is concerned for VI and Vim, I use Arch. So VI is not an alias for Vim. In a lot of operating systems, it is. One of my big problems with Vim, as is installed in a lot of like modern operating systems and stuff like that, is like parentheses highlighting and stuff like that. But also another big problem is the following. Let me just do that same operation I just did in Vim. Okay, so let me just right and quit here. I'm open up vi-sierpinski.cpp. I open up a new line and I'm gonna type in 80 I. Shoot, what did I do? Open up a new line above, and then I'm going to type in 80 I dash escape. Right? That was super quick. It happened in no time at all, right? Let me quit here. And now let me do the same thing in Vim. Okay? So I'm going to open up a new line beforehand, and I'm going to type in 80 I dash, just like I did before. I'm going to press escape now. Took 2 seconds before that appeared. Like, I know that's a little gripe, but there's a few other little gripes like that make me not like Vim. It's just slightly slower than VI in a whole bunch of little things, you know? It's just slightly worse in a few ways. In a lot of other ways, it's way, 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 way better. But in some ways, it's not better, you know? And so sometimes I'll be doing things and I just have to wait for like, whatever, Vim to do whatever it's doing. And it bugs me, you know? So that's kind of why I use VI, because there's just a few things in there that I don't like about Vim. And there's a lot of things in there that I know are really good, but I don't care about. Like syntax highlighting, I don't want, you know? But it's something that everyone uses and everyone wants to have. So, you know, Vim just has a lot of bloat to it that I don't feel like I need, you know? Let me go ahead and catch up on chat while I take a look at this visualization. Right, so this should be an equilateral triangle. However, now I have to change everything because it's low. I need to raise it up a bit. Okay, so we'll make it so the triangle's in the center of the screen and reshape it and all this kind of stuff. So we'll do that next. Let me catch up on chat. Let's see. Do you have an alias? I think I just read that one. But that might be calculus. Linear algebra. Calculus is also an integral part of modern mathematics. A convolution will make your renders faster. I'm doing rendering through FFmpeg, so I can't really attack that part of it. I can so relate. Thinking in procedures can make you unable to think in math. Yeah. Time related, well, not integral. Is an algebraic part break part of mathematics? Are you saying like an algebraic person? Yeah, I think algebra is definitely a big part of mathematics. Can your OS run OpenGL 3.2 stuff? Yeah, I don't see why not. It should be able to. Like using the float functions for computers offer humans need slide rules for it. I love how minimalism is your way. I use Arch too. Yeah, honestly, the reason I use Arch is just because I like the minimalism of it. I like the fact that, you know, your operating system is running off of like 200 megabytes of RAM or something dumb like that, some small amount. And I love that. I love the fact that, you know, this particular setup is using as little as I can. Basically, I get the most bang out of my buck. For the least amount of dependencies provides me the greatest amount of I guess efficiency. That's kind of what I go for. And yeah, you could argue that, oh, it'd be nice if you're using a tiling manager. There's all these different things I could do that could be better, but it is what it is. Let's see. I never had expected it to take so long. Do you know about geometric algebra? It's really fun to do. I haven't done it so much, but we might talk about it a bit more. Inverse trigonometric functions help me out. That's why I can't use IDEs anymore, just that it's that much worse. I often accepted suggestions before they appeared, which obviously don't work too well. I just want to say, hey, Rocket Sage, how are you? I had no idea that you were doing this because it's not my science, but man, it looks cool. Hey, I'm glad you're here. So if you guys don't know, Rocket Sage is another wonderful streamer. She does a lot of geology streams. She also plays video games every now and again. If you haven't seen her channel, definitely check it out. It's great. We sometimes rate her at the end of stream if she's live. But it just depends on time zones and stuff like this. But yeah, definitely go check her out. She's great. How have you been? So basically for any of those guys, anybody who's coming in and you haven't been to the stream before, essentially today we're creating fractals. That's what we're doing, specifically Sierpinski's triangle. And we're just updating the code to make it prettier. That's all we're doing. As far as a comment about IDEs, I I agree with you. I tend to feel like the gain you get for using this type of stuff can sometimes not be worth the cost of having to relearn everything in order to use the new system, right? Let's see. I'm well. Just wanted to see what you're up to today. How are you? Staying safe? Yeah, I'm staying safe. I actually, okay. So I quarantined myself in Boston for 2 weeks, and then I rented a car, which is relatively quarantined, and I drove down to Alabama. So I'm now hanging out with my parents in Alabama, and I'm doing that just because I don't know. It's nicer to be in kind of an open area without too many people around than in Boston, where there are a lot of people around. So that's kind of where I'm at. I just realized you're not in Japan anymore. I don't work fast, but I get there. Yeah, so I just left Japan. So December 30th, 2019 is when I left Japan. And I started working in the U.S. January 6th at MIT. And then since then, I moved to, yeah, I've just been moving around. Do you go, no, MIT, not Harvard. Let's see. There was something else the internet speed's fine. Like, I don't stream at a particularly high bit rate, so it's okay. If I streamed at a higher bit rate, maybe it wouldn't be okay, but we'll see. Okay, just MIT. Wait, what are you saying? Just MIT? MIT is great. Specifically in the area of computer science. It's pretty cool. Anyway, it's fine. It's fine. Leave it to a Harvard person to say that. I'm kidding. What does your algorithm do? Let's see. Does what your algorithm do is look at a random XY and check whether this coordinate is part of the set, or is it just a Mandelbrot thing? Or I just know nothing. This is doing something slightly different. So what that visualization is that you're seeing right there is something called a chaos game. Okay? So we have three functions, function 1, function 2, and function 3. And we have 3 points in space, A, B, and C. A, B, and C. Function 1 is going to be equal to whatever point's location plus A over 2. Function 2 is going to be the point's location plus B, B over 2. And function 3 is going to be the point's location plus C over 2, right? So all this is doing is it's going to return the midpoint. If you do F2 of A, it's going to return a point in between A and B to be right here. So what the chaos game does is it starts out at some random point, here, let's say, and it just chooses one of these functions at random, right? And it moves halfway towards A, then halfway towards B, then halfway towards C, and so on and so forth. And eventually, it finds itself on the Sierpinski triangle, where, it's slowly creating this triangle form in here. And so what we do is we remove the first few elements that weren't on the triangle, and then after it's on the triangle, it's on what's known as an attractor. It will be attracted to that object, and as long as it's on the triangle, no matter what function it takes, it will always remain on the triangle. So this initial point right here might not be on it. But eventually, after following these functions, it will find itself on it. And then once it's on it, it can't leave. That's why it's called an attractor. Any random point will be attracted to it if it's following this set of functions. Let's see. Right. Let's see. And there are places where it will never reach. Fixed points. Yeah, so A, B, and C are fixed points. I don't know what else would be a fixed point here. You'd have to argue with that. Argue with me about that, but we'll see. Okay, so now what I need to do is kind of resize this triangle so it takes up more space in the screen. There's a bunch of little things I need to do. So I'll go ahead and get started on that. Let's go down to the Sierpinski chaos. Here. For Pete's sake. Pretend I can't do anything. I am a miserable failure at this kind of stuff. And we are going to change the offset to be this times 5, okay? And we're going to make this slightly big. No. I want to change it to be 3. And we're going to change this to be 9, okay? And we're just going to recompile that, and we're going to see what that does. I have no idea. It should change the size and location of our triangle. That's all I know right now, because I wrote this code a month ago, and I don't remember what it does. Control-C. Let's see. No, you're not. You're quite smart. And then some. I appreciate that. So are you. Thanks for saying that. All right, so whenever this finishes compiling, we will then take a look at the visualization. We should see a slightly bigger triangle and go from there. Sadie KBR 1998, thanks so much for following. Really appreciate it. I took a pill that accelerated my brain, so now I'm stupid faster. I need one of those. It'll help me get to solutions faster by going through all the bad cases, Like if earlier today I had taken that for the climate simulations we were doing, Or not even climate simulations, for just the messing around with MPI state arrays, we would have gone through it much faster because we ended up throwing in the towel anyway. What is this? Doppler radar. Yeah, I'll take a look. Let's see. Ooh. Oh, what is this? Doppler VR red, F green, USB transmitted offset is exaggerated, LSB transmitter not shown. Oh, I'm gonna have to do this. VHF omnidirectional range. Were you just looking into this for something? What? How is this? Interesting. Yeah, it's cool. Thanks for showing it. I think this is it's still rendering. It'll take a second. Sorry about that. Let me just look at H-top here real quick. Oh gosh, this is getting awkward. I don't know what to say or do. How are you guys doing? Hope you're having a wonderful day. Oh, it's done. It's done. No more small talk. Every time that happens, I just don't know what to do. So here it is. Perfect. Now that is a perfectly centered and perfectly sized triangle, if I've ever seen one. That is exactly what I was looking for. Wow. Now that's pretty good. It's sarcasm. It's not what I wanted. Ah, dang. I wanted it to be in the center. It's not in the center. And okay, let me. All right, let's look into this. I'm currently blocking like 300 cores for another 5 or so days. Somehow it turned out that I have more free time during my master's thesis than I had during any other part of my uni life, so it feels so weird. Honestly, that's how it felt with my PhD as well, right? Like, when you're at a particular stage, sure, yeah, you're going through classes, but at some point the classes don't matter as much, and you end up not putting as much time into them. So you get more time, and you end up doing other things. To center it, you need to know what the center is, and set that point to x over 2 and y over 2. Right, so that's what I thought I was doing. But clearly I'm not. So let's figure this out. So what I have here is world.size times 0.5. Then I'm subtracting out a triangle offset. Ah, this will always have to be triangle size times 0.5. Okay, now for the y direction, we are adding in that triangle offset. So we made the triangle bigger. Let's just run this, and let's see what that looks like. Okay, and then we'll see. Thanks, Tommy Two Toes. I mean, yeah, thanks. Let's give that a run, and we'll go from there. So yeah, we already had that offset, but I just didn't interpret it correctly. Error while decoding frame. You can't see this error message because it's behind my face, but yeah, we have some error messages going on. Okay, we'll wait for this to render. Ubuntu, no, I'm running Arch Linux. Yeah. I'm so sorry. I know there's a meme about Arch Linux, you know, being like Arch Linux people feel like they're morally superior to everyone. I'm sorry. I just like Arch. It's fun. I enjoy it. I mean, you use whatever you want to use, man. I don't care. If you're using Windows, I don't know, or like modern operating systems like Temple OS or something, that's fine. Use whatever you want. I don't care. I just happen to use Arch. I like it a lot. That's it. When's the next Arch speedrun? Oh boy. Oh boy. The next Arch speedrun will be sometime. I want to make a video on it. It was so cool. I love doing that. Modern operating systems like Emacs and MATLAB. MATLAB is very far from an operating system. I will give you Emacs, but not MATLAB. I love how you went Windows or modern operating systems. I meant esoteric, but I said modern. Install Gentoo, never change. Gentoo, Temple OS is equal to modern OS. It's a thing. It exists. Oh man, Temple OS was a magnificent piece of software. Like, whether you agree with the guy's mentality or not, you have to admit the guy went for it. So for those of you who don't know, because maybe you don't know, let me just go to Temple OS. So this is what some people would consider to be the most, I don't know how to put this, the most amazing operating system that has ever existed. It quite frankly is better than every other. So okay, let me give you an example. When Heartbleed came out, you know, it was this big vulnerability. It affected every single major operating system, but not Temple OS. Temple OS was actually spared from the issues with Heartbleed and all the other security vulnerabilities because the main developer of it is simply a genius. He decided that Temple OS would not have networking capabilities. Therefore, it's not affected by any viruses. It's amazing. You know, it's simply you can't attack it. You know. The other thing is, in order to write this, he created an entirely new language called Holy C. Let me see if I can find it. Holy C. Oh boy. Oh boy. Holy C. Definition of Holy C. No. That's not what I'm looking for. Holy C language. It's like a religion-based operating system. And look, don't. I'm not saying that there's something wrong with that. I think it's really cool. But it's just the fact that some guy made this. It's so cool. Like, we live in a world where this exists, and I'm happy because of it. You know? You can't say this isn't cool. Like, it's got mini games on it. It has mini games that are only available on Temple OS, which is only run by like no one. And it's just cool. This guy's cool. I don't know. I mean, I know the guy died, and I know he had a whole bunch of weird like mental mishaps and stuff like that. But like, I love that we live in a world where that exists. That's all I'm saying. I think it's really cool that we live in a world where that exists. Okay. It's still offset by Y, so we have to fix that offset. Let me catch up on chat. Hold my Chrome OS. He ran at a train like a hero as well, supposedly. I don't know. The guy who made Temple OS is a bit of a nutcase. Definitely. I believe there is a Terry Davis stream on Twitch, even running old videos of him. At least there used to be one. I believe it. When will we get terminals that support graphics and sprites like Temple OS? What are you talking about, man? Are you kidding me? Are you kidding me? We already have that. We already have it. Look at this. Look at this beautiful animation we have in the terminal, right? Control C. I even have, you know the old SL command, right? Here's SL, the standard SL command that everyone knows and loves. Well, we've updated it. We have a new version of SL. Here you go, right here. It's perfect. I'm sorry. I'm just being a bit of a jerk. I'm so sorry about that. When we get terminals to support graphics, let's see. Only with neutrino transmissions, designed with divine specifications. But who had it then? Did he die? Yeah, he did, unfortunately. He got hit by a train. He was just sick. Train wreck, maybe. Religion. I probably shouldn't have a train up. Maybe let's go back to the anime one. Let's go back to the anime one. Okay. Religion is proven to be a sickness now with archaic technology valid. I'm not going to comment on that. I don't think there is a problem with religion as much as other people do, and I don't think I want to talk about it too much here on stream. I think we should maybe... I know we just talked about Temple OS, and I know part of the reason I really like it is because it's a religious OS, and I know I prompted this, but I think maybe we should... Maybe not. Okay. 5 out of 7 points, James. That's pretty good. 5 out of 7 is better than I did on a few of my tests in high school. Arthur Cho, thank you so much for following. Really appreciate it. No time to be soft. Extinction at hand at times. Right. Artichoke. Is that how it's spelled? Maybe. Holy cowabunga. Hey, Hip, how are you? God instructed Bill Gates to write Windows Vista? Maybe. Oh, no. Oh, no. We can differentiate between a cool work of art and a mindset. Okay. You're right. I think that's true. Okay, cool. Anyway, I just want to say this exists. If you were looking to show high resolution animations in your terminal, you totally can. It's called Sixel, Sixel. It's amazing. Didn't try Temple OS. It's one of those things that's beautiful because it exists. That's my personal opinion. It's just an operating system that was generated purely for religious reasons. And it's just an operating system built from the ground up by one guy. It's cool. Are you trying to compile the TF2 leaked source code? I don't know. TF2 is Team Fortress 2. I don't think anything else is true, so no. I think the answer is no. Peppermint Mint, pretty sure it was drugs because Windows was horrible. Oh no. Let's maybe not. I'm gonna get back to give you okay, so world size 0.5 plus triangle offset. So I'm gonna add let's do triangle offset times 1.2. Let's just see what this does. Again, I'm putting in some more magic numbers, but these magic numbers aren't as magic as the previous ones, so I'm kind of okay with it. Sun OS was so much better. I don't know Sun OS. Sun OS. What is this? is a Unix-branded operating system developed by Sun Microsystems for their workstation and server computer systems. The Sun OS name is usually only used to refer to versions 1.0 to 4.14. I think I've used one of these before. When I was at Los Alamos, I feel like I used a Sun Microsystem device before. Or maybe it was used in my old physics labs. Can you live code 3D graphics in the terminal like TempleOS though? I don't know. Hope all is well with everyone else. Good, doing good. Thanks for asking. Enjoying the mindful stream. Yeah, I'm glad you're here. I think everyone has said they're doing okay. Maybe someone's doing really poorly, and if you're doing really poorly, I hope maybe, chatting about Arch and TempleOS is helping somehow. I had to deal with AIX a lot lately. I don't even know what AIX is. Can you code 3D graphics in the terminal like TempleOS though? Okay, the answer is no, I cannot, but I'm sure you can, right? I've been wanting to learn more about Sixel, and one of the big things I've been wanting to do recently is learn how to make these types of animations. Like, again, this is amazing to me that you can show like high resolution visualizations in the terminal. You can even play video games in the terminal with these graphics, and it's so cool. Oh, is this done? Looks like it's done. MPV? That was not what I was expecting. Oh well. That's my bad. Okay. Let me think. What just happened? So let me see here. So the Y location is going to be world.size.y times 0.5 plus triangle offset, plus triangle offset, and then minus triangle.size times triangle points I of y. I see. Okay. So we have the triangle size, which is going to be 900. I just want to lift it up a bit. Just give it a little bump in a direction. So the triangle offset is going to be triangle size times 0.5. Let me take a look at that visualization again. So what I noticed with this visualization was we have one point here. So one of the external points here, but not in the other corners. So let me just try running this again right here. And I'm going to drop the number of frames to just be am I using Vim? I'm going to drop the number of frames to be I'm going to drop the number of frames to be 500. Because that's all we really need. Right, quit. Closing that terminal. Oh, no, I just... Oops. My bad. Let me just move this back over there. And maybe move this up over here. Okay. I thought I had another terminal behind it. That's obviously why I closed it. And we'll go ahead and compile this guy. Run /c Rapinski. And let's go CD projects. Simuleos and Fractal. I'm just running this again. We'll take a look at where all the points are and see what we need to do with them. Can you make the center point the literal center behind between the triangles? Yes, that's what it is. But the issue is that we have to give an offset for each individual point, right? So, oh, actually, that's a good question. So, because what we're looking for is if we put the center of the triangle, where's our triangle? So if we put the center of the triangle right here at 0, 0, what does that mean? That means, so this guy, it's a pain. No, so we don't want this to be at 0, 0. We want this to be at, so we want this point to be at 0.5, 0.5. That's what we want. And then what we're going to do is we're going to offset this by some number of pixels in the x direction, and offset this by some number of pixels in the y direction. I understand now. The issue is I'm offsetting it by the same number of pixels in the y direction, but it's not the same number of pixels. It's going to be the same number of pixels times square root of 3/4. I think that's what I'm looking for. I think that's it. I'll catch up on chat in just a second. Let me play this video. Yep, so all the points are in the right location. Okay, let's move this up here. There's a way to make this a bit better, but vectors, you heard of them? I'm just bad at them. I've heard of them. I definitely have heard of them. I use them a lot. I'm just bad. You know, that's the truth is I'm bad at this type of stuff. Okay. World of size plus triangle offset. So we're going to multiply this by square root of 0.75. So that's going to give us, yes, I think that's right. I'm going to compile that and run it. And we're just going to see what happens. Let's see. Control C. Let me catch up on chat while I'm waiting for this to render. They wrote it at the dream to Cancer as an... I don't know what you're talking about. Did I accidentally help again? Village idiot? We're all village idiots here. It happens. Just keep going. Yeah, I'll do that. Half of that. It's already half of that because the offset has a 0.5 in here. I think. That's... We'll see. But you're right. It should be half of that. If you have a triangle A, B, and C, and the center of the triangle is an empty space between them, you get the center of the blank one. Set that to be y over 2. Yeah, that's what I'm looking for. Nice. Okay. So if I just go to any other time we have a location here, let's look for loc there. We'll do location there, and I'm going to do triangle offset times square root of 0.75. Did I do 0.75? I freaking... It is what it is. I'm going to have to put this on the next line, because why not? Something like that. I missed a few streams, a few follows. Sorry about that. Empathy TV, Roku Ross, Fusion Unlocking, and Young Cheese. Thank you so much for following. Really appreciate it. Let's see, location here. Oh, it's only those two locations. Okay, so this should fix that visualization. Let's G++. Run this. And this should... when it's done, give us a visualization with a triangle in the center of the screen. That's what we're looking for. And then once we have that, we should be able to fix the other animation as well. And so we'll have the two animations ready to go. And then I'll go ahead and commit that, and then we can talk about what we need to do next. We'll just see. We'll see where we go. I've got another hour left in today's stream, so plenty of time. Well, 50 minutes or so plenty of time. And this is a bit of a longer stream, so my stream stamina isn't particularly high. I might be getting a bit tired in the next few minutes, but we'll see how it goes. MPV, that looks like it's in the center of the screen, does it not? Nice. And we can even increase the size of our... We can even increase the size of our triangle a bit. So Sierpinski Hutchinson should be above Sierpinski Chaos, because that's just how I wrote it. So if we increase this to be world.size.y times 0.95... what is it going to do? Let's go ahead and run that. G++ /Sierpinski. I really should have just created a large like class or struct that had all the parameters in it, but I didn't. And I'm kind of kicking myself now, but whatever. I'm not. Again, this is only going to be used for like one video and one animation for the algorithm archive, so it doesn't have to look that pretty. But I'm kicking myself that I didn't do that. I knew better. I just didn't do better. Man, oh well, that's what happens. Sometimes when you're so used to programming and stuff like that, you get stuck doing one thing and you just don't even think about it until you are too far along that it's the wrong thing to be doing. And that's where I'm at now. Let me take a look at that. MPV, not bad. Okay, so let's go ahead and fix the other animation to do the same thing as well. So I'm gonna do yank to yank, why not? Let's go up to Sierpinski Hutchinson, and then we go there. Up here, I believe, paste there. D. And in here, we're going to do triangle offset times square root of 0.75, and we should have another loc. There. Nope, not what I'm looking for. Here. Triangle offset times square root. Square root of 0.75. And again, I'm going to move this down to the next line. I feel like I did this twice, and I did. Oh well. Times square root of 0.75. And I believe this will be the right animation. Yeah, that looks right to me. Let's just go here. We are going to move this visualization so it is here. This animation will take a bit longer to render. But it looks pretty cool, so I'm pretty happy with it. We're in /Sierpinski. and I will catch up on chat. You have a disclaimer in your bio, man. You make your stuff work. It doesn't have to be perfect. I don't even remember what I said. What did I write? I think I wrote, in my FAQ, I think I had a question, why are you so ugly? And I just said, you are what you eat and I eat an ugly person. I think that's what I wrote. But then the question was, why is your code so ugly? And I wrote something about how I was a physicist or something like that. Planet continuation bias. Is this like a planned continuation bias? A related phenomenon is a planned continuation bias, also called "get there it is" or "press on it is," which is an unwise tendency to persist with a plan that is failing. Right, yeah. So let me see. What did I write in my bio? Why are you so ugly? My mother always said you are what you eat, and I eat an ugly person. My bad. Why is your code so ugly? Let's see. I have a specific niche, and my coding reflects that. Please feel free to tell me what I'm doing wrong and why you don't like it. More than that, feel free to submit pull requests later on my GitHub account. I'll look through them and try to figure everything else out. Okay, fair enough. The you are what you eat thing, and I eat an ugly person. That's like peak Simuleo's like joke right there. Like that's. You don't get that type of humor anywhere else because it's bad humor. Okay, cool. Visualization done. MPV. Come on, please. No, yes. Look at that. That's what I wanted to see. Man, I love this animation so much. It's just so cool. Okay, so I'm going to commit what we have, and we'll go from there. You ain't ugly, though? Depends on who you ask. If you ask me, I mean, it is what it is. Let me get some water. Also, my haircut right now is awful. I know that. It's in the awkward growing out phase. I know I need to grow it out a bit longer to make it okay, but yeah, it's fine. Oh, trust me. I knew you were talking about the animation there. I knew. Right. Okay. Is this going to be on the test? Asking for myself. You're tested every day when you go outside. Okay. So the next thing we're going to work on, I'm going to commit what we have. But the next thing we're going to work on is the fact that once this triangle is finished, there are still points moving about. That's what we're going to work on. What is actually happening in this animation? So what we're doing is we are starting with 3 points in space, A, B, and C, right? And what we're doing is we're having A generate 3 children, and we're having B generate 3 children, or we're having C generate 3 children. And then we're having each of those children follow an independent path. So of the 3 children of A, one will go on function 1, and it will, move towards A, but it's already on A, so nothing happens. Another will move halfway towards B, and another will move halfway towards C. And then what we do is we track those children, and those children, and those children, so on and so forth. And that's exactly what that animation is showing. It's just tracking all of the children with time, and their movement and all that kind of stuff. So that's why at the very start, if we, I don't know if I can go frame by frame. I don't think I can. Yeah, I don't think I can. At the very start here, I'm just trying to go really slowly. There we go. Oh, that's kind of ugly, isn't it? Yeah, okay, I'm generating, yeah, that's my bad. I'm throwing points out too quickly, so it's hard to really show that. But man, this start is so cool. Like this part right here, that's so cool. I love that. It just looks so cool. So the flying bits are dots moving towards A, B, or C. Yes, they're moving halfway towards A, B, or C. Change. Okay. So yeah, that's what they're doing. Okay, so now we have to talk about the next bit in the room. And again, let me commit this so we have something committed. Quit here. Git add sierpinski.cpp. And we'll do git commit -m, removing magic numbers. Okay. Right, that should do. And we'll do git push upstream, origin, master. So it's just on the Simuleos branch, and we'll go from there. Okay, so now the next bit we have to do. Let me just, I don't know, move around in my chair a bit. Kind of a bit. Okay. Okay, so we have 45 minutes left in the stream. And I think that's enough to tackle the next problem we have with this animation. Let's see. I just meant it looks like change is happening. Oh, definitely change is happening. You are totally correct there. I don't know if you can hear my chair moving around. I'm using like a, those like metal chairs, like those foldable metal chairs. I have like one of those foldable white tables and a foldable metal chair that I'm sitting on. It's not particularly comfortable, but I mean, it'll do for now type of thing, you know? So my back is just like, man, it's not feeling too good right now. Didn't notice until you did an exaggeration. Yeah, I'm pretty sure you can hear. I'm sorry. This is the content you see on Simuleos. Just let's just put this in the upper corner and let's move on to the next bit. Actually, let's watch this animation really quick because it's actually obvious what I'm trying to do when you see the animation. So if we move to the end of this animation, at some point, this point here, all of the dots are filled in. We have our completed Sierpinski triangle. However, children are still flying about, right? So the reason this is happening, or my belief as to why the reason this is happening, is because of the way we're doing the simulation. So I said this before, but I guess if we start at point A will generate 3 children, and then that will generate 3 more children and 3 more children. The problem is that the way in which we're iterating through this space, essentially, if we follow function 1, which is p plus a over 2, this child here will be at the same location as a. So this entire branch is completely unnecessary. I think what I might do is I might change this animation completely. So instead of starting at point A, we start at the midpoint between A and B, and the midpoint between A and C, and the midpoint between B and C. So that might be what I do. Let's go ahead and do it that way, because I think this will solve the issue entirely. I think. I'm going to try it. We'll see what happens. So vi Sierpinski .cpp. Okay? I'm going to go down to the first triangle points. Okay? What I'm going to do? I'm going to do yank and paste, and I'm going to say triangle midpoints. Okay? And what we'll do is we'll say triangle midpoints, $, and we're going to give it 3 elements. I think I can do this. We'll see what happens. SC vector vec. I think I need parentheses or something like that. Just okay. Now we're going to say 4. Screw it. We're just going to do it this way. It's going to be equal to triangle points of 0 plus triangle points of 1, and then we're just going to divide that by 2. I need an extra parentheses in here. Okay. I'm going to open up a new line, go here, and then do $, and paste it there, and then also paste it here, and then we're going to put a comma in there, and yank paste, and I believe this should do it. I just have to get the numbers right. So this is going to be between A and B. The next one is going to be between B and C. Come on, 2. And the next one's going to be between C and A. Okay, so here's our triangle midpoints. And then what we're going to do down here is we're actually going to initialize with those midpoints. And right, so we have to add those triangle midpoints in. So we're going to first create our A, B, and C. Then we're going to create our midpoints, and then we're going to move from those midpoints. So let's do it. Okay. This should be relatively straightforward. So we have triangle there. And I guess we're gonna do yank paste, and we're gonna create just an entirely new triangle. So we're gonna say mid triangle. This is how I write code. So let's look for where triangle is. Toma, yeah, thanks so much for following. Really appreciate it. Okay, so here's triangle points. Where do I define just triangle? It must be up here, right? 3 triangle points. So we do triangle there. So we have triangle size. Here it is. Yank paste. Actually, I can just do. I'll call it mid triangle. Of again 3. Okay. And what we're gonna do is we'll do, let's see, world.size, triangle I, make shared ellipse. So where's our triangle points? Here it is. So I have this location, and we'll do make shared ellipse for the location triangle here. And I'm just gonna grab all this guy. 1, 2, 3, 4, 7. So we'll do yank 7 yank, and we'll paste it down. Ah, it's 8, isn't it? Yank 8, yank, and we'll paste it down here. And we'll create a new location, which I'm just going to call loc. Sorry. And instead of triangle points, we're going to do triangle midpoints. I know this is dumb, guys. I totally understand. But it is what it is. Okay, so to make sure ellipse, and this will be the location, and this is going to be, of course, mid triangle of I. And we're going to add an animator, and this animator will be at 0 plus 10 plus 30. So we're going to do, let's do 60. Why not? I did something wrong. Thanks. Change semicolon to comma and second midpoint. Yes, thank you so much. Okay, so 60 plus I, and then it's going to be 90 plus I. Okay, and that should be the right animation. And we'll do mid triangle. And of course, we need to do mid triangle. Okay, this is dumb, but it'll work. And then I think I'm looking for another 60, I believe. Right. Ball add animator. I don't think that's what I'm looking for. What do we have up here? So we have draw frame. So where's our draw frame defined? Draw frame is defined here as 120, which should still be fine, I believe. Let's write that. Let's compile it. Oh, right. I need to do one more thing, which is where we have triangle points. Here, we should do apply for triangle. Triangle points is correct, but it should be, no, triangle midpoint. That's what I want. G++, does it compile? It does. /Sierpinski. Let's just see what happens. What's the worst case scenario? It could just look dumb, and that's fine. I mean, who hasn't looked dumb every now and again when trying to write code? It's the nature of programming. Okay, so let's see what this visualization looks like. Hopefully it'll look cool, and then we can go from there. Oh, my back is killing me. Oh, I'm just not used to these 4-hour streams, man. It's been 3.5. Well, not even 3.5, 3 and 15. And I'm, well, 3 and 20, we'll say. And I'm just, it's okay. It's fine. But yeah, if you guys have any questions, comments, concerns, ideas, anything like that, feel free to let me know, and I will do what I can to answer it as soon as I see it in chat. I realize some of the stuff that we do on stream is complicated, so sometimes it's a bit difficult to, difficult to follow. I do my best to make it as followable as possible, but sometimes it's not. That's it for me this time. See you again. See you again at a random point in time. Have a great day and stay safe. See you, Tommy Two Toes. Thanks so much for coming in. Have a wonderful evening, I guess, your time. And yeah, I'll see you around next time. For anyone who might be here from Europe, I realize it's super late European time, and I do really appreciate you being here. I'm trying to stream a bit earlier now and again, so I can catch that European time zone a bit more. Do you think at the end Rust will replace C++? I don't know. Everyone's been trying to replace C++ for a while. Like, people have constantly been like, this will kill C++ and all this kind of stuff. Okay, look at the new animation. We have those 3 points. We have those 3 points. And wait, let me just take a look at that. So we have those 3 points. We can wait 30, those 3 points. And then we have all these guys being generated. Okay, let's just watch the animation through. And then I'll answer that question. So, it might be super early in the morning, European time. So the triangle should be done soon. Oh, hello there. I see. We're going a long ways into this triangle. We got further because we have less children to deal with. Okay. Yeah, I'd buy that. So let me decrease the number of levels that we're going through so that we can get to the end of an animation. Because right now, we just ran into... do I have that as something I can read in? Maybe I should. So let's read in maximum level of 5. And let's go up to Sierpinski Hut Chaos. And we should have like level somewhere defined. Temp level, where did I define it? Must be here, level 8. So I'm going to DD there, And we're just going to read an int level up here. So we'll do int level. And I guess I'm going to have to move this down to the next line. Okay, write that. Go over here. We're going to run g++ /Sierpinski. And let's see what that does. Do you think in the end Rust will replace C++? Again, I don't actually have a good answer to that. I feel like C++ has slowly but surely been replaced in a lot of different places. I genuinely feel like C++ is a behemoth of a programming language nowadays with just too much stuffed into it. But at the same time, I realize it's super useful for a number of different things, and I do C++ code. I'm doing it now. Super early. It's 1:24 a.m. here. Still procrastinating from uni, so I can't complain. Right. Well, I mean, yeah. I guess I don't know. I don't know what to say about that. I'm sorry. I'm sorry that you're procrastinating. Okay. So here's our animation again. Let's just see what happens. Oh, well, let's increase the number of levels because that was maybe too short. So let's try 6. Let's do 7. G++ /Sierpinski. Let's take a look at that. Less is more. Yeah, I mean, that's where we're at. Let's give this guy a run. And then I'm not sure what we need to do from that point. I've got another visualization I want to do, but I'm not entirely sure how to do that. So I need to think about that. And I'll explain what the next visualization is as soon as this one's done. So we'll give this guy a run. Yeah, actually, that took a lot less time than I was expecting. We just had to I guess I didn't do exactly what I was wanting to do, but at the same time, I think this solves the immediate issue. And I think it makes it clearer, and people aren't going to ask questions about why all the children are running about even after all the children have been created, you know? Because there were a lot of points in the previous animation that were moving to points that already existed in space. And so that's what we're avoiding with this visualization. It takes a bit longer now because we have way more children running around, which is just a lot more computation to do. Again, this particular simulation is very compute heavy. Oh, I'm sorry about that. Okay, let's see what we got here. Have those 3 points. They generate a bunch of kids. And those generate a bunch of kids. Okay, not bad. Right. I'm going to try coloring these guys. I just feel like coloring these guys, and I want to see what it looks like. Yeah, there you go. There's your Sierpinski triangle. I mean, nice. One really cool thing about this that I'm just now noticing. Let me just go ahead and do a print screen here. Grab this, and let's run gimp screenshot.png. There's one particular point that is not shown. So let me just zoom in. I don't know why I'm doing gimp. I could have done Mirage or something like that. I'm going to zoom in. Zoom in. There's a point right. That'll do. Let's change this to red or something. Okay. This point right here. Do I have... No, it doesn't... Why doesn't that work? I should have pressure sensitivity. Maybe because this is too small. Let's make the size bigger. Yeah, pressure sensitivity. No, I don't have any. Crap. Never mind. Doesn't matter. Anyway. Also, where's my pencil? Like, whatever. I don't care anymore. She's back to where it was before, too. Okay. So this point right here. And this point. And this point. And this point. And this point. These are points that you would expect to see in the Sierpinski triangle, right? But the truth is, they don't exist in this visualization. And you might be asking, why is that? Oh. Oh, no, that's... Ah. That's interesting. I just noticed something, which isn't particularly great. This is messed up. Why are we overlapping there? I like the fact that these points are there. These points are not supposed to be there. But why are we overlapping here? Crap. Yeah, we shouldn't be overlapping there. Okay, so there's a few things we need to do. Why are the triangles merging? I only saw the overlap there. So you're saying there's overlaps elsewhere? Because, like, for example, there's not an overlap here. It's only here. I see. And also here. And also here. Okay, I see. So at the points where we have the three functions coming together, we have issues. Yep, okay, I see. Every level a different color. The triangles don't seem to be aligned, right? Yep. That is correct. Why? That's a very good question. Okay, so we're going to fix this today. That's what we're going to do. We have to fix that. It's just, we have to do it. Note that inside here, it's all fine. Maybe coloring it will actually help us anyway. So let's go ahead and do the coloring, and then we'll try to figure that out next. Yeah, let's just do it. Man, I was so excited because I thought we were done, but we're not. We're actually very far from it. So what I'm going to do is I'm going to define some colors up here. So we have white, black, and gray. And I'm just going to yank, paste, paste, paste. And we're going to add some new colors. So we're going to do blue, red. It's going to be kind of ugly visualization, but it's what I'm going to do. So just deal with it. And let's just make all the equals on the same line because I feel like it. Yep, okay. So for blue, it's going to be RGB. So RGB. For red, it's going to be RGB. So it's RGB. And for green, it should be RGB. Okay. And the point at the very top. I don't think the point at the very top was an issue, but yeah, let me see. Screenshot. .png. I didn't see that as an issue, but maybe it was. Let me see. Thanks, by the way, for pointing this out. I really appreciate it, guys. This is definitely helping. You're saying this point up here? That point was bigger because I set that point in particular to be bigger. This is point B. So it actually will be a bit bigger in the actual simulation. But also as a note, if I did put a point here, for example, it actually feels like, and maybe I'm wrong, but it feels like this point here, let me see if I can draw this better. It looks like this is crowding, and that's crowding, and this is crowding. And there's a lot of weird crowding that's going on that we shouldn't see. Crowding there, and there, for example. And maybe this is also related to this overlap area? I don't know. I'm going to color it. We're going to see what it looks like, and then we're going to try to figure it out from there. Pixels doing the societal distancing shuffle. Kind of in a way. And the point at the very top. Let me catch up on chat just to make sure I didn't miss anything. I don't think I did. Why are triangles merging? There are two more overlapping. Why doesn't it look like overlapping top left? Yeah. Okay, you guys are right. There's issues there. So let's see if we can figure that out. Let me color them first, because I feel like... I don't know if this will help or not, but maybe it does. So the point is going to be make shared. And here I'm going to say point color. Okay. And I'm just going to go up here and I'm going to say point color. We'll say color. Point. What did I call it? Point. Oh boy. Please. Let me type. Color. And I'm just going to say it's this. And then we're going to create a switch. So it's going to be switch on J. I hope I remember my switch notation in C++. And we'll say case 0. And we'll say point color. It's going to be equal to red. And break. Something like that should do. And we'll do yank 3 yank. Paste and paste. Case 1. This one will be green. And this one down here will be blue. Okay, so let me run this real quick. So we're going to do G++. Please compile. Thank you very much. I appreciate that. And let's see what it looks like. Right, you're right. There are some slight misalignment. So I'm going to look at it again once we see the colors, because the colors should allow us to see essentially which point moved from which function, right? So if they're following function 1, they're following function 2, they're following function 3. And that's what I'm kind of looking for here. Bulldor, thank you so much for following. Really appreciate it. By the way, Postavanjay, I don't know if I said thanks for following, but I meant to, if I didn't. Hey, how are you? Yeah, if I missed any follows or notifications or anything like that, please let me know. I am trying to keep up with it. But, you know, sometimes I fail. Like, for example, Rocket Stage hosted me with one viewer, and I completely missed that host somehow. I don't know how, but I did. So, right. Pixels doing societal distance shuffle. Right. So let's give this guy a second to run, and we'll take a look and see what it looks like. I don't know. It's probably gonna be ugly, you know, but that's fine. Right. I hope you guys are enjoying the stream. I really appreciate it. You guys being here. Let's go ahead and do MPV. There's another point, and ooh, that's kind of pretty. Let me go back to the start here. You should be able to see this whole triangle. I kind of like that. That looks pretty good. I'm a fan. Yeah, that looks really good. One time in my life, I feel like I made something nice. That's not true. I made something nice once before when I was like 5. But I do think the colors will help here a bit. Okay, so there's the final picture. Let me just do print screen. And let's see what we got. So we're going to do GIMP screenshot.png. Let's take a look at these overlap regions. The colors don't help at all, do they? I thought maybe. What are you making right now? Just what you just saw. We're making a Sierpinski triangle visualization. So we're working on iterated function systems and stuff like that. It's so cool to be here. Hey, I'm glad you enjoy your time. Again, if you guys have any comments, questions, concerns, feel free to let me know, and I'll do what I can to answer it when I see it. So let's see. So in particular, let's take a look at these overlap areas in here. So I'm gonna zoom in a bit. Okay. You know, that really doesn't give me any more intuition than the black and white one did. All I know is that for some reason this function is slightly too big. So I'm also looking at this crowding region here. And here. Why are you moving points full triangles? What do you mean? Why are the moving points full triangles? Oh, that's just because I'm right, so I know what you're asking. Let me just go ahead and show everyone else because it's not obvious, the question. So let me move this, full screen it, and I will just pause at some point. Yeah, let it, oh, maybe I already paused it. You're asking about, let me zoom in. So there's like a triangle. I'm just gonna do print screen again. Just open it up again. So there's a triangle here, for example. So let me zoom in. And it's sending 3 children, A, B, and C, right? So what's happening is some point generated 3 children, right? And those 3 children are being sent off into the direct, no, that doesn't make any sense, does it? Oh, I know why. I'm an idiot. Okay, it's because of this. Let me explain. Sorry about that. So it's because I do not have a time offset between this creation of, this incrementation here. So what this is doing is it's going through and it's generating 3 kids, right? And it's generating 3 kids at the location, at a particular location. So it's not that, those are not 3 children from a single point. Rather what it is I'm just making sure this makes sense. It is not 3 children from a single point. It's taking all 3 triangles from, so like if you have a triangle point A, B, and C, it's acting on point A, B, and C at the same time. I guess. You're right, maybe there's something wrong with that as well. Cool, thanks for pointing that out, because there's probably an issue there. Let me just read through this code and try to figure that out. So apply trite. 1. Could this be a floating point precision error? Maybe? Because at some point maybe I floor something and I don't mean to. Like when I put it onto pixels, I floor it. And so here's our midpoint function. So our midpoint takes 0.1 and 0.2 and returns 0.5 times 0.1 times 0.2 plus 0.2. If 0.1 and 0.2 are integers, they should be floats, but if they're integers, then maybe that's why we have the crowding, because it's just for some reason off by 1 or something. So midpoint of triangle points 1 point now. No, that has to be a float. Because then I set the location. So I do it in floating space, and then I set the location in pixel space afterwards. Could it be an issue with... Let me run the other visualization. No, that doesn't make any sense either. Gosh. Let me look at the visualization again. I don't know. I don't know why that crowding happens. I think the first thing I'm going to do is try to tackle Folster's question, just to make sure we understand why they're moving in batches of 3. And then I'm going to come back to the bunching, because the bunching seems like a more difficult question. The moving in bits of 3 thing is just because of how I programmed it, and I think that can be easily explained. Let me full screen this and take a picture. Cool. I'll take a look at that in just a bit. Nista ovo ne radi. I don't know what that means, but thank you, I guess. Magic. So cool to be here. Shouldn't the 3 points be sent off in different directions? Right. Okay, so let's figure out Folster's question first, just to make sure what I said actually makes sense. So, when you looked at the group of 3, you noticed that it was a red, green, and blue point, right? So that means it must be within this switch statement that we just generated. I'm so sorry. I don't speak internet useo. I'm sorry. Is that Italian? I'm sorry if I'm wrong. It just seems like it's Italian. But yeah, feel free to keep talking. I'm sorry if I can't understand what you're saying. What is it then? If it's not Italian, Serbian. Okay. I'm sorry. I just made a random guess. I should know Italian. I should be more cultured, is what I'm saying. Okay, so we're saying location is going to be apply trite, which is value seeing triangle midpoints, triangle points, right? So that means that... Right, so what we're doing here, yeah, we are iterating through, yeah, so what I'm doing here is I'm going through all the triangle midpoints. So what I'm doing is I create a trite string, right, which is going to be, you know, our set of functions that we're calling here. So it'll be function 1, function 2, function 3, function 4, or whatever this is. So it's going to be function 0, function 1, function 2, function 0, whatever, our string of functions that we're going to call. And then I act on midpoint 1, midpoint 2, midpoint 3. So that's the issue. So the issue is, yeah, that's exactly right. It's acting on 3 different points in close proximity, which is why it's doing that. I'll think about whether that's the visualization we actually want to do after we do the bunching question, because that's the question I'm not entirely convinced I know how to fix. So let's go up here, and I'll just have this playing up here in the upper corner while we think about the bunching question. Let me get some more water. I'm almost out, by the way. Okay. Also, guys, I have between 10 and 15 minutes left in stream. So if there's somebody that you want me to raid at the end of stream, please feel free to let me know. I mean, Adam's live, Tim's live, Loading Artist, Frecht Chemist, she came by the other day. She's doing a hunt for Tardigrade, Mospig, all this kind of stuff. Rocket Sage, again, she came by earlier today. We could definitely raid her as well. Let's see, Dowright, we've raided him before recently. Ginger Bill, I don't remember this guy much at all, but we'll see. But if there's somebody that you want to raid, just let me know if you want to do more science content or more programming content or more, I don't know, whatever type of content, let me know. Let's see. And we'll raid that person. So just let me know who you're interested in watching, and we'll go from there. It seems to me like the bunching is happening because the points are stopping short of where they're supposed to be. Maybe. If that's true, well then why are some of the points in the right location, but not all of the points in the right location? And why is it specifically at the edges of the triangles that we're running into these issues? And also, when we say bunching, it's more than just bunching, right? Because in some cases it's overlap, right? So there's bunching and then there's overlap, right? So it seems like in some places they go too far, right? So there's 2 issues that we're dealing with here. So let's do GIMP screenshot.png. And let's just highlight those 2 issues again. So I'm going to zoom in. So the one issue is the bunching, where we see some points, like these points in here, being absurdly close for some reason, right? And I don't know exactly why that is. But then we have this other case in, like, for example, down here, where we have the 2 triangles kind of moving over themselves, right? The whole level 1 triangles are shifted. The whole of the level 1 triangles are shifted. I just don't understand because I'm not inputting those triangles, right? Like, it's not like I just said this triangle goes from here to here. I'm literally just putting in the functions, right? So, and I thought maybe there's some integer casting being done here, but this is greater than a pixel off. Like, for example, this bunching is greater than a pixel off. Possible to run a DNA test to see where this kid's coming from exactly? Wait, where what kid is coming from? Interesting. Okay. Okay. So let's... Oh, I see. A DNA test to see... Aha, that's pretty good. Took me a second. To see where... I gotcha. Where the parent is. Since you're generating the triangles recursively, isn't the bunching the very same overlap, just smaller scale? I'm questioning that right now. So I argue it's different. Because if it were the same... Right? So this bunching... So this bunching is coming on near the corners, right? But like here you see the bunching, but this is where you'd expect to see overlap of the greater triangles, right? So this bunching is happening in the internal triangles, but it's overlap in the external triangles. And that's what I don't understand, why we have a difference between the inner and outer triangles, right? So, you know, this point right here is our starting location. That's where we're starting. We're starting at this point, you know? Similarly how we're starting at this point here. And, you know, this point down here. 1 second, let me get to it. Right? So we're bunching around the initial locations. Will this be in 3D when I put on red? Yeah, maybe. It does kind of look like that, doesn't it? The blue points make me think casting rounded issues. Yeah. Yeah. But we see the blue, the green, and the red points all generating similar issues. If you look closely, it looks like every single dot is jittered. In the cases the spacing is bigger, did the near points both round their positions? You're saying all points are jittered. Whereas I'm saying only points near the intersections of the two triangles are jittered. Maybe you're right. It's hard to tell because we only have 4 points on every element. Let me run this for one more generation. Discard changes. How long does this animation run for? So it's fully done halfway through. So let me run it for one more generation, and let's just see what happens there. So we're gonna go through 8 generations, I guess. And let's just see what happens. So we're gonna run that, and do we have enough time? I'm gonna render it for 4,000 frames, just a bit longer, just in case. G++/Sierpinski, and let's see what we got. So we might have to put a pin in this and think about it a bit more tomorrow. It's a good thing to think about over the night. Yeah, it's a good thing to think about over the night. It's just easier to see in the horizontal. Yeah, I think you're right. So while this is rendering, let's think about reasons as to why this would be bunching. So I'm gonna go up to the midpoint formula in here. So all we're doing is, sorry, my eye is itchy. I know I shouldn't be touching my eyes because I shouldn't be touching my face. Sorry about that. So we have vec midpoint here, which is a vec of 0.1 and vec of 0.2, right? And all we're doing is we're turning halfway between 0.1 and 0.2. That's it. That's all we're doing. Okay. So if we're calling upon function 0, we're going to do midpoint of point and triangle points 0. So we're midpoint of A. These functions are clearly working because most of the triangle is right? So it's clearly working it to some extent. Geez, where would it be coming from? Let me see the overlap with more children, actually. And let me see what that looks like, because that could be a key to understanding this a bit. I must have put a decimal point in the wrong place or something. Maybe, but yeah, maybe there's something like that. Let's go down a bit. This will take just a second longer to render, and we'll just watch the whole thing and try to figure it out. Man, this is a lot of code, isn't it? Um, Maybe there's some stupid magic number I put somewhere that I wasn't thinking about. Um, like, what's getting me is I don't understand why. Can you output the point's position as a matrix of coordinates? Uh, I could, but it's all generated in a weird fashion, so I don't know if that would actually give us any information. Let's full screen this and just watch it. Just for a bit. I mean, it's 4,000 frames at 60 frames a second, so it's a minute or two for the animation. I mean, it looks fine, right? Like, just looking at it, it looks fine. It's just you notice things that are wrong if you look closely, you know? Like, I just need to think about it. So let's look at the whole thing, and then after we see the whole thing, we'll go from there. Ooh, are we gonna get to the whole thing in time? Maybe this next generation is just too large. I mean, it is exponential growth, right? Like, that's what you would expect. And also, it's super trippy. Oh. Are we gonna get there? Ah, yes, we're done. So I'll just go ahead and print screen. So let's see what we got there. So we'll do GIMP screenshot.png. Okay, and let's just zoom in here. That is impossible to really see anything, isn't it? Yeah, it's impossible to see anything. I mean, we still see points missing, but you don't see the bunching in this animation. Or you know, we only see the overlap part here. Let me change this to white. Maybe that'll make it a bit easier. So we see the overlap here, but it's really hard to see the bunching at all. What? I don't know. Why don't you output images instead of the video? I could output a video. Yeah, I could output a video of just the 4,000th frame or something like that. Yeah, I could do that. It's just I already had this in there, and it would take longer, I thought, to edit the code than output a video. What's most suspicious is that the starting points aren't the vertices of the neighboring triangles. What do you mean by that? The starting point this should be a starting point. So you're saying it's suspicious that this is our starting point? Maybe. Oh, you know what? You are right. This line should be perfectly along. What is going on there? Discard changes. Why isn't that right? What? So let's look at where we define triangle midpoints. So we have this mid triangle defined. Triangle midpoints is going to be triangle points divided by 2. Is there a casting error here? 0.5 times. We're just going to put that here, here, and here as well. Let's remove this divided by 2. I don't know. I'm just, at this point, I don't know. That's ugly. I guess yep, I'm doing it. Sorry. I mean, there could be. It doesn't matter. 0.5 multiplying by 0.5 is technically faster than dividing by 2. I mean, it doesn't. No one cares, but technically faster. Yay for VI. 0. Yeah, right. But I thought it would cast it. Anyway, why is there a 4? Where'd that 4 come from? Okay. Let's see. 0.5. Maybe this is it. Maybe that's the whole issue. Okay. It was harder to see with 8 sets of children, so let's change that back to 7 and change this to 3. See what happens. Give it a go. Fulster is owing, which means he understands everything. What's the issue? Tell me. Please just tell me what I need to do. Let's see. I'm out of water, but I only have like 5 minutes left in stream, so should be fine. You guys didn't say exactly who you wanted to raid at the end of stream. Let's see. What OS is this? This is Arch Linux. Thanks for asking. Okay, so it's rendering, and we'll just see what it looks like afterwards. Oh man, every time I render something, you can hear it just go crazy. Are drawn ellipses drawn at the center or the corner? Are the drawn ellipses? You mean points A, B, and C? Oh. Okay, I see what you're trying to say. They should be drawn at the center. I think. Yeah, I see what you're saying. But it should be drawn at the center, but maybe you're right. Maybe it's not drawn at the center. We can check that next. Yeah. Let's just see what this looks like when it's done. MPV. But actually, that's such a small offset. Yeah, we're still offset by a triangle. Right. So the question is, why is this line here, not perfectly aligned with this point there? Interesting. Interesting. Mr. Sarcastic, thank you so much for saying that. I really appreciate that. Yeah, I appreciate all the support you guys are giving the channel. I mean, just in terms of things that you're saying and all that kind of stuff. Yeah, I'm really just getting back into the content creation stuff, and I'm happy to be back. I'm happy to be back, you know? Serpinski Hutchinson, we're going to do triangle midpoints. The midpoints are drawn at the right location. So that should be fine. The midpoints are drawn at the right location. Just fine. It is all of the other points that are not drawn at the right location. Is this because I somehow... The parent location will be applied trait of the parent string triangle points. Oh. Maybe that's it. Maybe I gave it the wrong initial position because I am a crap programmer. I'm surprised you're not pissed answering the same question. Many teachers pissed answering the same question. I mean, I'll be honest. I don't mind it. Like we see the same. It's Twitch, right? People come in all the time. This isn't a lecture, right? Like I don't have a time to be here. Like in class, if someone asks the same question twice, like that's a waste of 5 minutes of class time, right? Here on Twitch, it's not a class. It's we're hanging out. We're doing programming together for fun. And so people asking the same questions or suggesting the same things usually won't bother me unless there's some sort of time constraint pushing me to get this out as soon as possible, which technically there is. So let's take a look at this visualization and we'll see what it looks like. How the points being animated. They're literally just being animated by moving one point to the from the parent location to the child location. I think I just found an issue where the parent location was phenomenally different than the child location. So the points were being sent from one location to the wrong location after that, which could have been the problem. So that looks like it's animated, and no, we're still. This is the same animation. That is the same exact animation. So apply trait goes from parent string, which is going to be 1 minus the child string, and then we do triangle midpoints using triangle points as our functions. We're going to have a location, which is going to be 0.5 minus the triangle offset. Triangle offset times square root of 0.5. Triangle offset times square root of 0.5. Is there something different between these two location generators? I know I should be doing the same. Making very clear the reason. Yeah, I mean, again, I do my best to answer questions as clearly as possible. If you guys have any questions, I mean, the thing is, you guys are helping more than you're hurting. You know, asking the same question again and again just makes you rethink about things that you may have already thought about, but it's still useful, you know? And the same is true here. I mean, everyone's helping me debug here. It's a useful thing to have. It's just this location and parent location, we're casting it onto I'm sorry, I hope you're not tired from questions. What's draw frame plus 30? So draw frame is going to be what this is, it's a vector of frames that we're drawing on. So draw frame is the frame that we're starting the drawing on. So this means that like we're starting on frame 30. And so the reason we start on frame 30 is because it takes, maybe 30 frames to generate point A, B, and C, right? So here, I'll just show you the animation. This might be faster. So it takes 30 seconds to generate points A, B, and C, then 30 more seconds to generate the midpoints, right? And then from there, draw frame plus 30. So after a bit, we then wait for just a second before drawing all the other points, right? So this is a time. So draw frame is a frame in which we start drawing on, right? And so it's an offset. And it's just an offset to make the visualization clear that we're going from one point to the next. Or we're doing one thing and then the next thing and then the thing after that. Let's see. So draw frame. So here we're adding an animator. So that's what the draw frame plus 30 is. So we're starting from draw frame and then we're going from draw frame plus 30. So the big problem we're trying to figure out is the following. Screenshot.png. And is that if you look at the end visualization here, there's a couple issues. So let's scroll in here. And the big thing is this triangle, we shouldn't be seeing a triangle here in this visualization. Also, there's a small bunching in these areas that we're trying to figure out. So the visualization isn't perfect. And this is what we're trying to figure out. Maybe the location? Yeah, but right, it's got to be the location, right? Like we have to be, the way that we're casting this location just has to be wrong somehow. I mean, that's just how it has to be. So let's take a look at the other locations. Yeah, so it knows that because when we're adding the animator, we say so this is how the animator works. So it's point at animator, right? So we're going from draw frame to draw frame plus 30. So between these frames, we are, oh, sorry, it's this one down here. So draw frame to draw frame plus 30. We're going from point location. We're modifying the point's location from the parent location to the new location, right? So that's the issue. So we start draw frame, we end draw frame plus 30, and we go from the point's location, we go from the parent's location to the child's location. That's what we're doing. Like most of the time it works, but then it goes bottom. It messed up. Yeah. Let me check something else out really quick. Yeah, right. So this bottom line is fine. All of these lines between A, B, and C are all correct. But the point between the midpoints is wrong. We never code that up. We never code, so this line right here, let me open it up in GIMP. I mean, it should be. Well, that's simple enough to change. So let's just modify this so it takes a second longer to draw. So the animation here is going to go to 60. Right? So it's going to take 60 frames to get there. And what we're going to check to see is if the offset is worse now. So let's go to G++, /Sierpinski. And in this case, the offset should be less, is what we should see. So we should see less overall overlap. What about the max bound of the for loop? The max bound of this for loop in here is just, it's going through, we're going through all possible children. So we have this tree, and so A generates 3 children, then its children generate 3 children, its children generate 3 children. So what this is doing is it's going through all the possible paths up to that level in the tree. Okay. After this, guys, I will go ahead and close shop for the day. So again, if you have someone that you want me to raid at the end of stream, let me know. I'll go ahead and commit what we have, and we can think about it a bit more. Because, yeah, maybe Fullster. I think you're right, maybe Fullster, now that I think about it some more. But yeah, so if there's somebody they want me to raid at the end of stream, feel free to let me know, and I'll totally try to raid that person as soon as I can. Or like, at the end of stream. You know what I'm trying to say. I've been streaming for about 4 hours now, which is a long stream for me, so I am a bit tired. Right, so let's check out this visualization. MPV? Okay, so we should be expecting to see... Yes. Okay. Let's just let it finish up. And we will compare this screenshot. Okay, so let me go ahead and pause this. Do here, move screenshot.png to screenshot, and we'll call it bkup.png. And let's just cd into pictures or something like that, and move screenshot star here. Oops. Now we're going to take a screenshot here. So let's full screen it, and then we're going to do print screen, and then we're going to do the same thing there. Okay. And let's see, star. Right. So let's go ahead and take a look at that. So we're going to do right. Can I open up two files at once with GIMP? Oh, that was gummy. GIMP, pictures, screenshot, backup, and screenshot .png. Right, so yeah, we have two images here. And let's just zoom in a bit. So here's the one. This should be screenshot. Should just be screenshot, and this will be screenshot.png. Okay, so the overall distance is here. Okay, and the overall distance here, that looks less. It definitely looks less. So it looks like Folster was correct. We're just not getting the final position in that animator, which means it's not a particularly good animator if we don't get that final frame. The offset does look smaller to me. So I think what we need to do is update GathVL so it there's just like a less than or equal to that we need to update. I think I can do that right now. CD no, I don't think it takes an end equals true keyword. Let's use source animators ls vi vec animator here. It says update const int frame. Right, maybe it should. Mr. Stochastic, thank you so much for following. Really appreciate it. So maybe because parent location look have multiply squared, why are they the same value? So that square root of 0.75 is an overall offset to the triangle that moves the whole thing up just a bit, so that the center of the triangle is the center of the visualization. So that's why that's there. Asking chat who to raid equals winning. The offset looks smaller to me. It does look smaller. So let me write this down so we remember to do it later, but I think you're right. The big issue here is just that GathVL needs to be updated such that, I don't know where to write this down. Do I even have somewhere to write this down? GathVL needs to be updated such that the final frame of the animation is, the final point. So final frame. Maybe there's an issue with this, probably, because probably he's just doing like some simple time stepping. So probably it either overshoots or undershoots, and he just chose to undershoot it. Like there could be something like that that's happening, but we need to look into that. So we might look into that tomorrow. Overall, I'm relatively satisfied. Let me take a look at this visualization one more time. So let's just open up GIMP, pictures, screenshot to .png, and let me take a look at the bunching, not the overlap, and see if that also became less, because I would believe, yeah, it definitely does. Yeah, it definitely does. There's no like dot there. Okay, perfect. Okay, so I'm relatively happy with that. Even if we just have to do a slightly longer visualization, I think that should be fine. Possible swap A, B, and C parents if they see if things change. I think it's okay. I think we figured out the issue for now. New questions, but what are you using to draw on your computer? Yeah, I'm using a Wacom tablet. Actually, this tablet is my primary tablet for, like, I use it as my mouse. This is my mouse. So this right here is my mouse. And I don't know, I just started doing that because my mouse broke, and honestly, I need the tablet anyway to draw on stream. So I figured let's just use it for everything, and that's kind of what I've been doing. The big issue is, like, so if you look at my mouse right now, it's at the center of the screen, but right when I put it on the tablet, it teleports over there, or up here, or over there. So that's one thing you have to get used to. You can fix that now. I don't think I can, because I couldn't quite figure out how to fix it. So it says vec animator update const int frame. if vec pointer end frame is greater than start frame, and frame is less than, if we do less than or equal to end frame, maybe that will work. Yeah, let's try that. Yeah, let's just see what happens if we try that. So now we'll do make lib, I believe is what I need to do. Make lib, maybe it's make library. Vi. Make file. Wait, where is it? Oh, I need to go back one more directory. I think it's make lib. Okay, so now I made the library. cd into simuleos, fractal, vi Sierpinski, .cpp. And let me change that 60 that we had before to 30 to make it so it's a slightly broader like error that should be generated. And then hopefully it we don't see the overlap as much. So let's change this to 30. Okay, so now we're gonna do g++./Sierpinski. Oh, hello, Sierpinski, and let's see what that looks like. And then we'll be good to go. But yeah, so the tablet is a bit weird again because your mouse kind of teleports all over the place. But actually, just today I created a new command, which is tablet toggle is what I call it, which makes it so it's now a relative mouse instead. So now it acts like you'd expect a trackpad to work or something like that. And if I press it again, it goes back to the old form. This is particularly useful because I couldn't play Guild Wars, and I know that sounds really bad, and in fact probably I shouldn't have updated this because now I can play Guild Wars, but I couldn't play it before because when I played it, here I'll show you, actually let me show it to you now. I mean, why not, since we're waiting on the visualization to render. So we're going to cd into, let me do this so you can't see it. Storage, Guild Wars, GW, wine, gw.exe. Yeah, let me show you this error. Okay, so I'll show you the error and then we'll get back to the stream. So enter. Okay, so now you should be able to see me again, I believe. Let me check really quick. Okay, so here's the, oh, I did it again. Okay, so here's my character. The issue was, because this mouse hops around like this, if I try to change the screen location, it just does this. Which is like impossible to play because I can't ever get it to, I can kind of control it, but yeah, I can't really do anything with it. So the character just, it's hard. It's really hard to play because like, it's just hard. So then if I do the toggle, tablet toggle here, then when I play, it's way easier. Like, it doesn't do that weird spinny thing anymore. So yeah, now I can officially play Guild Wars, which I couldn't do before. So, dang it, let me switch back. So anyway, I'm so sorry. That was kind of a waste of time. I don't know why I showed that to you. It's just mainly because the tablet moves all around. Okay, let's just show the last visualization, see what it looks like. So we're gonna do mpv temp video.mp4. See what it looks like. And you're right, it's perfect. There you go, Foldster. You did it. Nice. Nice. Good job. Okay. So I'm going to go ahead and write and quit. I'm going to do git add Sierpinski .cpp. And we're going to do git commit -m added color to Hutchinson operator. Okay. And we're going to cd back a few directories. And let's also update gathvl. Cd gathvl. Git brand remote, I believe. So I do have an origin. So let's do git pull upstream master. This is such a small change. I'm actually just going to directly push to master. Git status. Git add source animators vec animator, and then we're going to do git commit -m making animators and on the appropriate frame, something like that. Git push upstream master, and that should be fine. Let's see, I blinked my eye for a second. What was the fix? It's just a less than or equal to. That's basically it. Cool. What? Oh, maybe I have to do a pull request. Okay, so let's do git, crap. Git checkout. What if I do, this is gonna be super messy. Git push, push origin master. Everything's up to date. Git, what? What? 1 second, let's solve this. GitHub.com. Okay. Come on. Let's do, gathvl should be. Yeah, oh, that's mine. Now, is this recent commit in this? No, it doesn't look like it. Updating.gitignore, small change. Adding tab to make file. Okay. So, what am I going to do here? Git log. Making the animations. What is origin? Git remote -v. Origin should be, yeah, it's my own. Git push origin master. Why can't I push to my own master? Everything's already up to date. No, it's not. Let me catch up on chat here. Cool stuff. Looking forward to the next stream. Blink my eye for a second. I think I'm mostly caught up. Looking forward to more streams. Thank you all. Right. The fork something. Yeah, so my fork should be here. Git log. Yeah, it's in the git log. When I tried to push to upstream, which should be the, it gave me, failed to push some refs. Updates were rejected because push branch tip is behind its remote. Upstream master. I thought that's what I did. What? Okay. Well, let's just go back to the start. Git reset. Why does it say I'm up to date? November 26, 2018 is the last update here. I'm almost positive, not the last update to GathVL. The last update here is February 10th. So, why am I not able to... Yeah, why am I not able to push to... Yeah, I can take a look. No, I don't think I need to rebase. All I'm trying to do is push to my own master. I'm on branch. I'm on... Oh. Yeah. I understand now. Okay. Yep, I understand now. My bad. What is it? Cherry pick, right? I think that's right. That's great. I'm gonna do vi source vec animator, source animator, vec animators, and we're just gonna add the less than or equal to. It's literally one character. So now we're gonna do git commit. Why not? Source animators, vec animators, -m, allowing animations to end on correct frame. Okay, git push, origin simple fix. What? Oh, I did the wrong git checkout, didn't I? I forgot a B. Oh, whatever. I know this is really messy. I'm sorry, guys. I I know I shouldn't do that. I know I should have my own feature branch. I get that. I understand. Whatever. Don't care. It's on my own master. Let's just create a pull request, and I'm not going to worry about it. So let's just do GathVL here, and we're going to do new pull request, and we'll do base master. Nope, we're looking for LEIOS. What? Compare across forks. And we'll do Laos GathVL, base master, and we should... Did I not push it? What? What? Commits here. F5. Allowing animations to end on the correct frame. Laos GathVL base master. Algorithm archive GathVL base master. It is committed. It's right here. What? What? Did I not add it correctly? I didn't get commit. It should have... Yeah, there it is. It's just one line changed. And... Not the... Oh, wait, maybe... Yeah, maybe you're right. Maybe it needs to go the other way. This way to... Crap. Yeah, I should have changed this one. Laos. And then this... Yeah, okay. Yeah, whatever. This should work. Great pull request. Wow, amazing. Let me just make sure this works the way it's supposed to work. I'll do the animation one more time. Let's do make lib. Oh, this is taking a bit longer. Give it a second. Yep, give it just a second. And then we'll right. Now with CD back, and let's just run that very same animation we just did. Projects. Actually I can just run it over here. G++ /Sierpinski, just to make sure everything works, and then we'll end stream. That's it. Sorry, I don't know what was going on with that freaking Git stuff. I'm tired. That's my only excuse. But yeah, that'll actually be it for the day. Once this is done. Oh well, things happen. Not too worried about it. So again, just let me know who you want me to raid at the end of stream, and I'll go from there. Let's see. Let's actually just see who's live again. So Adam's still live, but I feel like he'll be ending soon because he usually ends around this time. Doombox TV is playing Guild Wars. If you guys want to watch some Guild Wars, I'm pretty sure you don't, but maybe you do. We've got Fractals Chemist, Rocket Sage, Strager, Dowright, CM Griffin. Let's see who else is here. We've got Cosmo Quest, who are doing weekly space hangout. Maybe that's pretty cool. What do you guys think? Just give me a record. What do you think? Space or programming? No, not space or programming. Science or programming. Give me or art. It's up to you. Let's take a look at the animation again. So we're gonna do MPV temp video.mp4 full screen that guy, and let's just make sure it looks correct. And it does. Wonderful. Okay. So we'll let this play out. No one really gave me any suggestions, so I'll just go with my gut. And I feel like I'm gonna go with the person we haven't rated recently. So probably, I feel like we haven't rated Rocket Sage in a while, but I feel like we rated Fractals Chemist recently. Besides, Rocket Sage was on our stream earlier. Wait, let's go ahead and raid Rocket Sage. That seems fine. Oh, you want to do some programming? Okay, so if you want to do programming, then let's do, then you also said science. Let's see, who haven't we done on this list? So, loading artists we haven't done in a while. Tim, I feel like we did Tim a few days ago. Rocket Sage we haven't done in a while. Let's do Rocket Sage. Let's just do Rocket Sage. She was here earlier. You know, I appreciate that. Let's go ahead and do the raid. Start the raid on Rocket Sage. Right. Okay, that's it for the day, guys. Thank you so much for coming in. Have a wonderful day, night, afternoon, morning, evening, whatever time it happens of your time. And I'll see you guys around next time for the next episode of Simulaos. Tomorrow we will be starting at 6 o'clock p.m. Eastern time, but I will hopefully be starting at the 4 o'clock p.m. time a bit more frequently. Q Joel, thank you so much for following. Really appreciate it. And that's it for now. Thanks guys again, and I'll see you next time. Bye guys.